Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on four powerful pillars: the Sharp platform, bringing Web 2 to Web 3; the Sharp token, fueling growth and rewards; the Sharp Rewards app, where you learn, earn, and grow; and the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth. Own your future.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp Reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep. Every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp Reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Well, my mic was muted. Thanks to the technology, it picked it up. Hi, everyone, and welcome to day 3 of Software Architecture Conference. This is the 4th edition of this conference that we are doing. We have had incredible first 2 days where we had more than 20 plus sessions, and we are almost halfway down. We're starting the very first session of the day by Puneet, who's going to talk about the architecting Agentic AI Systems on Microsoft Azure platform. And Puneet is a chief architect at Microsoft. And without any further ado, Puneet, welcome to the Software Architecture Conference.
Thanks, Simon.
Well, thank you so much, Puneet. I'll let you take the stage right from here. I'm adding your screen to the stream. Everybody can see your screen, and we'll take the Q&A towards the end. Next 30 to 35 minutes is all yours.
Thanks, Simon. Hi, everyone. I'm Puneet. I work for Microsoft. I'm based in Singapore, and you can connect me on LinkedIn. Today's topic is something that's very close to my heart. We've all seen and heard a lot about the AI solutions coming up. So the key question that comes up a lot of times in my discussions around the globe is, what if AI could not only think, but autonomously plan, act, and refine its own decisions? Are we able to reach to a point where AI can potentially plan and act and refine, right? So this is what we essentially call agentic AI. And in this session, we'll talk about some best practices, patterns, and frameworks. But before we go to the agentic AI as a, I think let's take a bit of time to switch the screen. So before we go on to the agentic AI, I think we've all seen and heard about RPA, whereby we were actually looking at an ability to complete repetitive tasks. Like it could be inputting new hire information into an HR system or billing anything in an invoice. From there, we've gone to a point where we have said, all right, let's talk about a chatbot which is able to answer questions, right? So user asks something and it goes back to the chatbot that says, what's the dress code in office? So it moved on to more of a frequently asked questions. And today we are looking at a single AI agent, which is like ability to perform an action, right? So if a employee has joined for the first time and you want to order a laptop, you potentially talk to an agent, a chatbot which can take some actions, and with a human supervisor in the loop, you're able to take those actions. What we are seeing, though, is that this is now converging into a system which can kind of take those actions, but is able to collaboratively solve complex tasks. It's not just taking one task, but coordinating and identifying and fixing some of those tasks. So this era that we are in is seeing a rapid growth from the age of artificial intelligence getting defined in 1956 to generative AI being defined in 2021. And we all know how generative AI in the last few years has kind of transformed. The last 4 years have been phenomenal in the growth of AI, and we are seeing that this topic that we talked about, agents doing thing, is moving from generative AI to the concept of an intelligent agent, right? So the journey of generative AI to an intelligent agent has been with a lot of changes that have come into the modalities of execution. We had earlier models that could understand text. We had different models that could understand vision. We had different models that could understand audio. But today we are looking at a mechanism or an approach where these multi-modalities are available in a particular AI model. And we are looking at capabilities like text generation, chatbot, code generation, human level experience, and intelligent agent, all framing up together to give new kind of capabilities to the end user. Things like real-time audio generation. We've seen AI now being able to generate images that are very real in that nature. We have seen videos getting generated with all the emotions and the text and the sound, all those VFX kind of effects coming into the picture. We have seen now AI getting capabilities of calling functions, which means you're not just relying on getting information, but also performing certain text, which means at a broader level, we are now passing larger context to AI than what we were used to pass earlier, right? So in from even GPT 3.5 until 4.0 and the recent OSS launch of OpenAI models, we're seeing that the context has been increasing, the number of tokens that it supports has been increasing as well. So this journey from generative AI to an intelligent agent has transformed from a no agent, which is where we essentially took a document, applied some kind of LLM prompt to it, and said, help me with a summary of this. And the document came out with some answers, some summary of it, or maybe some additional information from a document which is pretty long in that sense. To a point where we now go into a single agent, and single agent is where you ask a question to an agent, it performs some kind of search algorithm on the documents to retrieve the right kind of document on which you then apply an LLM prompt and use some data to get the right answer. So instead of looking at a document, now we're looking at multiple documents and an agent that goes and gets the relevant answer from a set of documents. And now we are on the point where multi-agent systems are forming up. And I'll double click a bit on this multi-agent system. That's what the core topic for today is, which is where we need to first understand what an agent means when we are moving from that a chatbot kind of an experience to an agentic kind of an experience. And this is fundamentally important to understand that we start with a concept which is a user experience. We all know user experience is what defines the modalities here, whether it's an audio, video, or a text-based concept. And we have a foundational model that is supporting the end-to-end experience. But the crux of an agent is also in the middle layer that you see there, which is called orchestrators. An orchestrator is essentially the brain that gets the information from maybe one model, maybe multiple models, maybe multiple knowledge sources, and then performs a particular kind of an action. Uh, and sometimes we look at these actions and this knowledge to be remembered so that in future we can provide some kind of personalized answers. And all these things happen autonomously in this kind of a system. So let's take an example of an agent, right? So if we have to do a booking of our trip, very common aspect of what we used to earlier do in the pre-agentic AI kind of a concept is a query LLM model that would go and search and would just give us some itineraries. And that itinerary would be based on knowledge available on the web. But that is a bit of a simplistic agent per se. What if we add actions to it to say, find the best ticket for me? This is something that I would want you to go ahead and book my itinerary. That is where the actions come into picture to perform those things that you want the agent to do on your behalf. So it's acting on behalf of the user, on the user's uh, consent. But then it then drills down to, do you want to really give the information or personalize the agent every time, or do you want the agent to remember your some of your previous conversations and profiles and then form a kind of a memory based on which it gives you a answer or a itinerary that is more customized to you. So this kind of an agent, we're talking about four key capabilities. We start with memory, just what I spoke about. We talk about tools, planning, and action. And let's double click all these things because these are fundamental capabilities that drive how an agent's output should appear, or how an agent can become more and more intelligent. We call this as reason and act, because this is not a one-way traffic that you provide a particular information to the end user at one go and that's it. It's not something that we had like a single shot or a multi-shot approach, but it is more of reason uh, bit on the answer that you're providing and then change your actions based on the reasoning. And this is seconded by, let's say, first the tools. So if you look at the tools, these tools can be web search, could be code execution, or could be some API calls as well. So let's take, we spoke about the itinerary creation, which involves a web search. We can also look at scenarios where you have information available in some kind of a document or some kind of a large Excel sheet, and you want to find some analysis, do some analysis on that massive data, which is where a model uses tools like code generation, potentially looking at writing Python code that analyzes that Excel sheet on the fly. Uh, and that Python code gets generated and executed on the top of the data to give you insights. So we are seeing more of these patterns evolve around toolings that use code generation to solve complex problems. There was a time where the LLM models couldn't perform math to that accuracy, but with code execution and generation and execution capabilities, we are seeing that the agents are becoming much more smarter, also in not just in reasoning, but also in the ability to perform complex logical things. This also means that you could potentially have a code written by an agent to go and call a particular API, retrieve the answer from an API, and then massage that information and give it back to the end user. The other aspect of a good agent, which is what differentiates an agent primarily from a chatbot, also is around the planning. So I briefly spoke about reasoning and acting. Uh, One of the key aspects of planning is also self-reflection or self-critique, that did I perform this task as the end user wanted? And when we talk about reflection, it is about reflection on the reasoning, reflection on the execution in an objective way, so that you can kind of improve. And the second aspect of planning is looking at a task and then breaking it into a smaller pieces of work, which I call it as goal decomposition, so that individual task or the individual smaller set of goals can be performed accurately and measured accurately as well. So planning involves a lot of other activities. Reflection, goal decomposition are one of the key ones that are there. If you go into the memory, there are two different types of memory. One is a short-term memory and second is a long-term memory. The difference between the two is one is more conversational in nature and second is more of a persistent one that is available as a behavior or a personalization that the user expects across all the conversations that it has. So imagine if the agent knows some of your information around your preferences, whether you like a red-eye flight or you prefer a flight in the mornings or in the afternoons, or you prefer a non-stop flight or you prefer a pit stop somewhere. These are some kind of memories that are essentially long term. It's more of personalization kind of a memory, and that memory helps in giving you answers that are really relevant. So not every time you have to provide an information to the agent to give you an answer in a particular way or to consider your choices. If the agent is able to look at the long term memory, it becomes much easier for the agent to tweak and give you the answers accordingly. So, in nutshell, if I look at this, an agent is what we are talking about, an LLM, some kind of large language model with predefined instructions on how do you uh, plan, how do you remember certain things out of the planning, out of personal choices, reach out to the tools that give you some information, and then perform necessary actions to execute. But if I go a bit deeper inside the agent, there are four key areas that are fundamental in customizing a large language model. The first is around prompt engineering. This is something which has been discussed multiple times in different forums, and it revolves around crafting precision or adaptive prompts to give you the maximum model reasoning without changing the model's core architecture. It's like the model exists there, and you are kind of telling it what it should give you through multiple different prompts, whether it's a single shot, multi-shot, chain of thought, whichever way, it all classifies under the prompt engineering. We also have a different way of retrieving information, which is called the RAG, a pattern that sees different forms and factor these days. This is primarily relying on external knowledge sources. And the idea here is that while a LLM model can provide you some information, this is to actually enhance the accuracy and reduce some hallucinations that the agents may have or the LLM models may have. So this is basically giving them the right information or narrowing the scope of information retrieval based on the search, and then bringing an adaptive answer based on the information that is there. So this primarily relies on getting the right information from whatever external sources you have. The next step, a little bit more complicated, is around fine tuning, and this is where fine tuning and small language models have a bit of a decision to make. These two approaches are primarily to get better contextual understanding and task alignment, but fine tuning is basically looking at the base model and then providing it domain specific data so that you can kind of train it on and get the right answers which are domain aligned in that sense. And SLM models are like small models. They can run on a small device like a phone or a laptop. So they're a little bit more cost effective in that sense, but they have to be tailored for a particular task itself. So I think we covered different areas, and we'll look at how do we move from an agent to an agentic AI. So when we look at agent to agentic AI, we are looking at similar such agents talking to each other. Now, one of the common thought process, if you've been in the IT industry, you've seen similar things come up in the microservices world as well. So imagine an agent being a microservice that is hosted in a cluster now, or multiple different microservices hosted in different clusters. So when users are actually calling an API within a microservice, the microservices used to be able to either resolve a particular query from it itself, or used to go and reach out to another microservices to get the information, whether it's a synchronous or an asynchronous call. Multi-agent system embarks on a similar kind of an approach, whereby we are looking at a user calling an agent and that agent that relying on a particular other agent to give that information. Now, this could go in a different ways. It could go in an approach where a user is calling an agent and that agent is actually a coordinating agent, and then it's giving a call to a retrieval agent and a code generation agent. So this goes as a different pattern where a coordinator is actually assimilating information from different places and bringing it together as a consolidated response. If we have to double click a bit on the pattern, we talked about simple agent. Network orchestration is also one of the patterns in an agent where it follows like a mesh topology or something, that where the agents uh, have an awareness of different agents in the ecosystem, and they invoke the right agent based on what is exactly required. So here there is no coordination per se, but the discovery happens or across the agents in a chatter mode, and the comms are based on the task at hand. There is another pattern which we talked about, the orchestrator. Now, orchestrator takes different shapes. On the left hand side is a simple orchestrator that's calling three agents. Now, you can actually have hierarchical orchestration as well, whereby there is an agent that's sitting at the top, which is, let's say, an organization specific agent, then is forwarding to an HR agent, to a finance agent, and then within HR agent there is an employee onboarding agent, there is a expenditure agent, and so on and so forth. So a hierarchical orchestration is basically a concept that can best resonate to a master and a child bot that you used to have some time ago. There is also worker and retriever kind of a pattern that we see in the agents, which is a worker and a reviewer. So basically, the worker is executing a particular task, and reviewer is actually reviewing whether the execution has been done properly. The difference here comes when a worker and a reviewer are actually having two different potentially LLM models, one trained on the execution, one trained to review the execution. So here, while you see the two boxes as LLMs, the key here is that the LLMs may be of different models, maybe SLM, and they are actually reviewing the outcome that to its accuracy. On the right, you also see a custom orchestration, which is very similar to a network-based orchestration, but it's more of some agents are sequential in nature, some are hierarchical in nature. So this is very specific to a particular business problem that you're trying to solve. So these are some of the patterns that we see based on a particular use case that you want to adopt for an execution, right? So let's take a sample case study and see how, if I have a problem statement, how would these orchestrations come into picture. So imagine that I want to do a digital payment trends in Southeast Asia, and this is what users are looking at. This is one of the use cases that I want to onboard a particular agent for. And when a supervisor agent looks at it, it uses technical stack like an Azure OpenAI or semantic kernel, and it detects the goal is market research. So supervisor agent now takes a call that I need to do market research. And to do the market research, I need to compose this into 3 tasks. This is where the planning, the decomposition of the task comes into picture, where 3 tasks that it identifies is to collect statistics, reports, analyze the adoption growth trends, and summarize findings. This goes to then 3 different agents. One is a data agent, analysis agent, and a summary agent. Each of them come with different set of queries. So a data agent would go and do a RAG to get some information from the market. It would go and query digital payments in Southeast Asia 2024, get the PDF report, use Azure Form Recognizer or something to get the data out of the PDF report and get a structured data set. So if you look at this, this is not just LLM, it is also doing some other cognitive services to extract the information using the RAG model. And analysis then comes back with running some Python code and doing some time series sprint and identifying the 3 drivers and flagging out something which is an outlier. And then going and creating a first pass summary that this reached to a particular percentage led by mobile first economies and how did it work. But if you look at the last statement there, the supervisor prompt comes back with saying add regulatory and competitive insights. So this is where the React kind of thing comes in, where the summary agent identifies what's the next action to be performed. And it could go essentially giving information to the supervisor agent to do a particular task again. So the supervisor agent then reviews all the sub-agent outputs, validates its completeness. So here, we're not just passing to the different agents, but it's also then the LLM is trained to validate the completeness and then give a final response back to the end user. So this is a typical flow, one of the typical flows using a supervisor-based orchestration that we saw. You can have different scenarios requiring different patterns of integration between different agents. Again, I want to remind you that when you're looking at these agents, the key concepts again that come handy are a domain-driven design, like you was to follow in microservices, but then also look at the right LLMs and the tools and the memories that you need to second your design decisions, to second the agent's capabilities in the system. So if I summarize this, we looked at different things. We looked at a supervisor agent that breaks down and delegates tasks. We looked at a data agent that fetches data, analysis agent that applies some logics, statistics, modeling, summary agent that crafts the end user response, and then it's an execution. Execution is basically parallel. On the right hand side, you have tools that can support you in this aspect, whether it's Azure OpenAI semantic kernel, cognitive search, web search, APIs from Bing. You can apply different technologies to get the input from the different agents. Patterns, you have planning, you have hierarchical planning that breaks down the task and assigns role, does parallel execution, reflection, and orchestration. So one of the other aspects to think about when you're planning an agent is these agents need to be small enough to perform a particular task and should have the right privilege to do only that task. A couple of months ago, I've written a few articles that go into the governance side of the agents. We're not going to cover that, but in this topic. But when you look at the governance aspects, one of the key areas is how do you tighten the scope of a particular agent to not have a lot of risk on your plate. You kind of give them small bite-sized tasks, make sure it's measurable, and the roles and permissions are tied to the T. The next part, what I want to talk about is around frameworks and toolings. I'm going to keep it light on this. In Azure, we have a AI Foundry agent service that allows multi-agent workflows. It's open and interoperable tool, and it then looks at trust and enterprise security as well, right? So at a high level, we are looking at external systems on the left-hand side, an orchestration service that is sitting in the center heart of the service that has the policy management, the memories, the tools calling, code execution environment, and multi-agent orchestration. Beneath that is application platform. You can have an app front and back end database and an infrastructure which is secure in that nature. And on the top, you have the foundation models that the agent orchestration service then interacts with. You can also have your custom AI models. So if you're looking at a service or a model that is kind of hosted within your environments, you could look at a hosted custom AI models, or you can host using AI Foundry into your system, right? So if I look at the overall system architecture, a system architecture on the top is where your workloads reside. You have a layer of network security through the private endpoints and compute resources. You have Cosmos DB, where you can have a short-term memory or a Redis cache which can store short-term memory. You can use storage accounts and databases for long-term memory. You have Azure AI Search, which is for the RAG patterns that you would want to retrieve, and then you have the Azure Container Registry there as well. So these are all predefined AI system architecture that you can leverage from Microsoft to accelerate your journey on AI. Few things to click on. Best practices, there are many of them, but I believe there are 5 key best practices that come in picture. One is around the scalability. Often we start with the MVPs or POCs, and POCs then eventually get into the production. But choosing the right pattern, even for an MVP or a POC, is extremely important, because we never anticipate how many complex tasks we will essentially then have the same agent solve. So breaking it down using the domain design patterns is important for scalability. That is where the multi-agent interaction with either an A2A or an MCP-based protocol to get the information from the sources or across the agent becomes important. Reliability is key. While we are having AI agents do a lot of heavy lifting for us, it is important to integrate reflection and guardrails to catch errors. These guardrails are not just um, LLM-based guardrails, but also a reviewer kind of a model that I spoke about some time ago. So, do you have a LLM model that reviews another LLM model to see whether the the tests are performed in the right way? Uh, Human oversight is absolutely essential. So we need some checkpoints to make sure that the model is performing, and also have triggers that that alert triggers that tell the human that if things are going south, or something is not being performed in the right sense. Security compliance becomes must. Zero trust, absolutely essential right from the time when you're training these models using DevOps, with your data cleansing and everything, to the point that these models get called up from a particular API endpoint. How do you make sure that you have the right security and compliance, the right data retention policies, observability across the stack included? So underpinning this is responsible AI. There are pillars of responsible AI around ethics, fairness, compliance. You can have a look at it. It's important to find the right principles of responsible and start this during the envisioning itself. Um, One of the key things when we talk about responsible AI is around safety, and I want to double click a bit on the safety. So when we are looking at safety, it starts with your data set. Uh, it is important to have your test data set, test your prompts through the application endpoint, use AI where possible with the safety evaluations to have the AI assisted data set generator, get the responses, have the evaluation results, and you can use the Azure AI Studio's automated evaluations to accelerate the evals across the LLM stack. So the key question here in my last slide is, I'm keen to know what are you building next with Agentic AI, and please type in across in the comments and welcome any questions that you have.
Thank you so much, Puneet. That was a very crisp session. I think it's a very good session to start the day. We'll take a few questions from the chats that we have. I'm gonna first remove this one and add this. There's a question coming from Sarthak, and he's asking, when designing the supervisor or orchestra, what are the key principles for balancing a predefined rigid workflow versus allowing the agent to dynamically plan and delegate tasks on its own?
A good question, Sarthak. So I think the key aspect of an orchestrator is to be able to identify what are the capabilities that are available in the agents underneath that, right? So that discovery and the key definition of what capabilities can it be addressed is extremely important. Now, if you have the capabilities already known, there are areas where you can use the LLM to kind of um, I could say decompose the task and then take a decision. Some of these areas where a predefined rigid workflow breaks is around the intent analysis and then drawing the actions around that, right? So I would prefer if you have these capabilities predefined and then let the orchestrator find out by itself that these are the agents that I have, rather than putting too much on the rigid workflow. A rigid workflow works best when you have a structured collection of information, as in step one, step two, step three, and then fill up a particular form. You need 4 data points to fill up a form. That's a rigid workflow. You can use that in that area, but sometimes when you have to think on the feet, like we sometimes as humans say, that is where the orchestrator should kind of plan dynamically.
Thank you for answering that. I agree to Rohit that your slides are very good, actually.
Thank
Those
you
are
so
very good
much.
slides. There's another, Kant Singh is asking, how do you decide whether a task is better suited for a single complex agent or a system of multiple specialized agent?
How do you decide if the task is better sort of single or complex? Okay. Um, from my experience, I think look, like the analogy I gave, right? Microservices based analogy
Hmm.
that serves the best for designing agents as well. Uh, an agent should have a particular domain capability to solve, right? And that is the single unit of work. If I go back to the solid principles of software design and architecture. It goes from that same principles allowing even here. So find that right boundary from a particular um, domain of problem that it has to solve and delegate it there. That way, it allows you to also have finer grain of R back on the capabilities that you want to have, finer control on the RBAC for, um, finer control on the LM that is getting utilized, fine tuned, or whether it is through the prompts or through SLMs. So then it is much more measurable rather than having an LLM and an agent that does everything.
Perfect. Thank you. Thank you for answering that. We'll take a couple of more questions before we move to the next one. I think folks really liked it. There's a question coming from Sakshi, and she's asking, what's the biggest mistake you have seen a team make when moving from a proof of concept to a production ready agentic AI system?
Uh, there are many actually, but I think if I have to make it, if I have to simplify, a proof of concept is usually. I think the fundamental problem starts from the proof of concepts definition. Sometimes we start with the proof of concept which is technical in nature,
Hmm.
and ready agentic AI systems should solve a business problem, right? So when we try to fit that technical solution to solve a business problem, that is where we kind of make a technical thing work suddenly somehow in that sense. But actually, it should be the other way around. You start a proof of concept that is more from a small piece of work that is an MVP, something that can go live into production, and then you
Hmm.
start building those capabilities, into it. So essentially, your proof of concept is production ready from the maybe not first sprint but maybe second sprint onwards, shippable product in that sense. Then you are looking at a more agentic AI system that's workable. Otherwise, it's trained on a smaller set of data, which is POC kind of data,
Mhm.
not responding accurately to randomness that people can put into the agent, and all those things tend to dissatisfaction to the users.
Perfect. Thank you. The Saurabh, he just dropped a comment, failing to design for scalability, reliability, and observability from the start, treating the POC like a prototype instead of foundation. That's a good comment. Thanks.
Yeah,
Thanks,
it's a good
Saurabh.
comment. Yeah.
We'll take one more. We'll take one more. We'll take one from Scott. He's asking, can you provide a practical? Oh, I don't know how you do that. Can you provide a practical example of human in the loop collaboration workflow within an agentic AI system?
Yeah, so I think I spoke about the tools where the agent has a
Mhm.
tools and a memory and all, right? So think of it this way, that you want to onboard the same example of onboarding an employee into the system, right? So
Yeah.
there could be scenarios where you're calling an HRMS system to perform an action, which is where a human in the loop comes in. A human in the loop comes in to review an action before it is taken. Uh, my recommendation here is that anything that impacts human beings directly, whether it is a sensitive use case that you're handling or a confidential use case that you're handling, that is where human in the loop becomes extremely important, right? So the human in the loop can be for reviewing the action that the AI has suggested, or as a maker checker, essentially, that yes, this action is going to be performed, but is this action correct? So before it gets executed, you kind of take a stopgap and see that yes, it is right action or not. So some of the best practices there that I've seen is also looking at human in the loop to review an AI response, that yes, the AI took a right response, and that thumbs up or thumbs down, even on the AI's actions, are basically going as a feedback loop to the LLM model, that this action that was performed was right or wrong. So you're basically fine tuning from the end user's action in the loop itself and saying, let's improve this. So it's measurable in that sense, and you are using an evaluation in that sense, evaluation framework to train the AI.
Thank you so much for a detailed answer, Puneet. And I was just checking the local time of Singapore, and I realized it is 9:35 p.m., which means I'll have to let you go. Although there are quite a few more questions in the chats, we won't be able to take those. Any final thing, Puneet, you want to add before we move to the next session?
I'm Thanks so much, Simon, for this opportunity. I think I'll be keen to see how Agentic AI, the people who attended this session, shape up the Agentic AI, and happy to take any questions offline in LinkedIn. Thank you so
Yeah, all
much.
right. Thank you so much, Puneet. A good night, and thank you so much for being a part of this conference. It's an honor.
Thank you so much. Bye.
All right, ladies and gentlemen, that was an absolutely amazing session upon Agentic AI by Puneet. We now move to our next session, but we have about a couple of minutes, so we'll take a quick commercial break and see you in a bit.
Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on four powerful pillars: the Sharp platform, bringing Web 2 to Web 3; the Sharp token, fueling growth and rewards; the Sharp Rewards app, where you learn, earn, and grow; and the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth. Own your future.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep. Every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Hi, everyone, and welcome back to day 3 of Software Architecture Conference. It's now time we move to the next session. And the next session is on one of my favorite Azure services. It's on Azure App Services. I still remember when it was called Web Apps back in 2014. And Microsoft Azure was called Windows Azure. I only look young. I am not young. I'm getting old. The next session is about architecting resilience web apps with Azure App Services. And joining us for this session is Satya Karki. Hooray! She's a senior application developer, Microsoft MVP, .NET Full Stack, CSharpCorner MVP. So without any further ado, hi Satya, and welcome to the Software Architecture Conference.
Hi, Simon.
It is so good to
Thanks
see
for
you
the
after so long. Right, I think the other
yeah.
day we had Rijwan, and today we have you. It's all like one family. All right, Satya, please feel free to go ahead and share a screen, and then we can get started.
Okay, let me first share my screen.
You know what's very interesting, this learn with Rich sat, when we were first looking at these pictures, we thought that you all are AI. In the beginning, when you all were publishing articles on CSharpCorner, this picture,
Yeah.
right? Everybody
Yes.
thought that you all are AI. Okay, I see your screen. I have added it to this stream.
All right.
Everybody else can see it, and next 35 minutes is all yours.
Okay, thank you. Let me open my slides. Is my slide visible, Simon?
Yes, Azure.
Okay. Hello and greetings, everyone. I'm Satya Karki, and I'm excited to take you on architecting resilient web app with Azure App Service. It's a Microsoft fully managed platform for building web apps, APIs, and the mobile backends. In this session, we will explore how it enables the developers to focus more on their code and less on the infrastructure or managing the server, all while benefiting from the secure, scalable, and serverless ready environment. So this is the agenda of today's session. So we'll begin with what is serverless in Azure, introduction to Azure App Service, why we need the App Service, benefits of App Service, its a plan, pricing from the student to the enterprise, developer experience, and the language support. And we will move for the features of the App Services, and then there will be one small demo, and we will discuss about the use cases. About me, I'm Satya Karki. With profession, I'm a senior software engineer. In addition to this, I'm Microsoft MVP and CSharpCorner MVP, as well as Microsoft Certified Trainer. I have more than 13 years of professional experience in software development and data, mostly with Microsoft technologies. So now let's begin with what is serverless in Azure. Serverless computing means that you don't manage the server, Microsoft does. The infrastructure is abstracted away. Azure handles the provisioning, scaling, and maintenance. So you can focus on the writing code and the development side. Many people think that serverless means no servers, but that's a myth. Serverless just means you don't manage the infrastructure or the servers. Azure takes care of it, so you can focus on the application development side. It's event driven, scalable, and pay per user, but still you have a full control on this. So this model helps you to build the application faster with a fewer operational headaches. So you don't need to think about the infrastructure, managing the server and the deployment things. Azure will take care of your applications by itself. So Azure offers different varieties range of the serverless services to help you build the scalable event-driven applications without managing the infrastructure. Azure serverless offerings has Azure Functions. It handles the code executions on demand, triggered by the events. Logic Apps lets you the automate the workflow with a low code interface. Azure App Service, while a PaaS can scale like a serverless when combined with the features like the KIDA or the premium plan. Event Grid routes the events between the services, while the Service Bus and the Event Hub support the messaging and the real-time data ingestion. For containers, Azure Container App is there, and it provides the serverless hosting with auto scaling and microservice support. Finally, the Azure SQL database and the Azure Blob and Event Grid give you the flexible on-demand compute and event-based storage triggers. So the together all these services form a powerful toolkit for building the modern cloud native solution. So we can build the modern cloud native solution using all these services and the serverless offerings for our application. So what's Azure's App Service? Azure App Service is a fully managed platform for the web apps, REST APIs, and the mobile backends. It is a platform as a service, the PaaS, meaning that without worrying about managing the underlying infrastructure, you can quickly build, deploy, and scale the web apps and APIs on your term. It supports Windows, Linux, Docker, and the custom containers. Additionally, it supports the various languages, programming languages such as the C Sharp, Node.js, Java, Python, and the PHP. Moreover, it has features like the built-in load balancing, auto scaling, custom domains, SSL, and much more that we will explore in the demo later. It is highly scalable, trusted, and secure and fully managed platforms for the application. So there were common deployment challenges that the developer were facing earlier. So before the app service, developers often struggle with the infrastructure setup, scalability limit, and unreliable CI/CD pipelines. Security and compliance or the manual tasks earlier. Monitoring lacked the depth and the visibility. There was no proper monitorings and the application insight and the log management that gives the clear idea about the what's going and what's happening in the applications. Developer used to face a trade-off between the productivity and reliability. Now let's see today how the app service addresses each of these problems. Azure App Service offers the built-in DevOps support, automatic scaling, and the zero downtime deployment slots. It integrates with Azure Monitor, Azure Key Vault, and Identity Services with a 99.95% SLA. It's reliable for the production use. This platform takes care of the operational tasks, freeing up the developers or the software architecture to focus on the other features, UX, UI, and the innovation of the development side. Now let's come to the key features of the Azure App Service. Azure App Service supports the multi-languages, as I already mentioned, C Sharp, Java, Python, Node.js, PHP, and it has a multiple deployment options. For example, we can deploy from the GitHub, we can use the Azure DevOps, we can use the FTP, we can use the zip file, and the Docker containers also we can use. Uh, as well as we can use the Azure CLI and the PowerShell script. Azure App Service has a different deployment slot, such as for the deployment slots for the UAT, deployment slots for the QA, and the deployment slots for the productions or the production, and the deployment slot for the development environment. So you can swap the each with the zero downtime. We can swap the one slot with the another with the zero downtimes and do some fixings or the investigations in the production site. Easily and maintain the downtime of the application. Additionally, it has a built-in authentications with the Azure Active Directory, with the Google, Facebook, Twitter, and many more others. It has a VNet integration, hybrid connections, as well as it has a features of the TLS, SSL, custom domains. And another feature is a live logging and the diagnostic and the application insight. So you can see your apps log stream as well in the Azure App Service. There are different types of the plan. App service plans determine the compute resources for your the applications. Free or the F1 plan that is great for the students and the small test projects. Basic plan is for the low traffic applications, and standard and the premium plans that provides the better performance, scaling, and the VNet integration. Isolated V2 plan offers the private VNet access, better security, and is ideal for the enterprise needs. So you can choose the right plan depending upon your uh, need and your budget, traffic, and the traffic volume that comes into the applications, and also the isolations that needs for your organization. Azure App Service serves the different use cases. For students learning, you can use the free tier, GitHub Student Pack, Visual Studio Essentials for startup and the SMEs. You can choose the pay as you go plan, which has a low operational overhead and can scale as you grow. Enterprise requires the features like the private environment, regulatory compliance, and the regional scaling. So App Service delivers all of these. So getting started with Azure App Service is really easy. All you need is the Azure subscriptions. You can use the $200 Azure free account credit to explore it. App Service supports the web apps, APIs, and the mobile backends, whether it's a small personal project or an enterprise grade application. It scales to your need. So now let's go and create a app service in the demo. So I have already logged in into my Azure portal. So here we can my mouse is not working properly. Let's create. So here is the option that we can create the web app, static web app plus the database. So for this demo, I'll simply select the web app. So we can select the subscription, resource group. Mm, So I'll just give the instance name. So this is the feature that we can secure our default host name. If we check this on this, then it will secure the unique. But for this demo, I can just turn it off. And whether we have to use the we are aiming to use the code or the containers, there is an option. So I just simply select the code, and the runtime stacks, we can select the different languages, whether it's for the .NET, Java, or the Node, PHP, those are the option, Pythons. So for the simplicity, I'll just select the .NET 8 LTS, and I will select the Windows. The region is loading Central Canada. While selecting the regions, we should be more careful that some latest and the newest features comes to the America and the Europe regions. It will come, the sometimes the new features comes late to the Asia and the other regions. So if you need the latest features of the Azure App Service, so we can select the US or Europe. I'll select the Central US. So now I don't know why my mouse is working slow. So let's go to the next. The database, for this demo purpose, I will not select the database. We can move to the next. While creating the app service, we can select the database also. For the deployments, if you need the continuous deployments, we can just enable it, and we can authorize it through the GitHub account. If you click the authorize, it will log into your GitHub accounts, and we can authorize these applications, and we can select the organizations, repository, and the branch from which we want to deploy the application to this service. That's the option here. So for this demo, I'll just disable this continuous deployment option. Okay, basic authentications also we can enable and the disable for simplicity of the demo. Let's move next. For networking, whether these applications will need it for the public access, or you want to just do for your the private access of the organizations, that's the options. Enable the public access, and this we can do from here. And virtual network integration, whether you need the integration with the virtual network or not, that's also the option. So I can just turn it off and move with the as it is. So now comes the monitoring. We can enable the app insight for the application monitoring, whether we need the app insight or not, that also configure. But once we create the app service also, later also we can go and modify these settings. That's not a problem. So now let's move to the next. With the default, I just turn on the application insight and the application to the Central US region. So let's go another one is a tag. Tags are the name value pairs that enables you to categorize the consolidated billing. So we can categorize the billings based on the multiple resources and the resource group. It will be easy to monitor the billing. So it's good to use the tag. For example, application demo created by, I'll use this tag. And then we'll move to the next, review and the create option. So now let's create. It will take a few seconds. Until then we can move to the slide and explore the detailed feature of the Azure App Service. So now let's move for the Azure App Service features in the details. So as I already showed that the Azure App Service has the authentications and the authorizations that includes the authentication and authorizations with the Azure AD, Google, Facebook, Twitter. We can do the role-based access controls, RBAC, and the token validations with the MSAL and the SDK. We can secure the APIs with minimal code changes. This makes the integration and the modern authentication easy and the fast. So we don't need to worry about the authentication part of the code. So we can use the default available option. For the deployments, we have multiple ways to deploy. We can use the CI/CD using the GitHub Actions or the Azure DevOps, manual push via the local Git, FTP, or the zip file that also available. We can use the IDEs like the Visual Studio or the Visual Studio Core for the deployment, and we can use the containers from the Docker Hub and the Azure Container Registry. So just you can just pick the methods that fits your team's workflow, team's skill set, and your organizational need. So based on that, you can select the deployment options. So for languages, Azure supports the different languages and the broad range of the languages, as I already demo in the while creating the app services. It supports the .NET, Node.js, Java, Python, PHP. So you can bring, in addition to this, you can bring your own runtime too. This flexibility allows developers to use their preferred tools and the frameworks based on their skill sets and the company needs. And you can select the language while creating, and also if you need to change later, then you can do from the configuration also. For deployment, there are different types of the deployment slots. For such as for the testing in the staging slot, we can swap the production with the zero downtime, use the traffic splitting for the A by B testing or the blue green deployments. It improves the app quality and reduce the release risk. So if there is any issue in the production or the live site, then we can bring that code, that we can swap that slot with the development slot, and then we can debug and check the issue and fix quickly in the development and test the development side, and then again swap it back and push it to the production side. So in this way there won't be any downtime of the applications, and we can fix the issue also. So that features is available in the Azure App Service. Beside this, Azure provides the scaling features for your application. Vertical scaling is for the changing the instance size, and the horizontal scaling is for the increasing the instant count. You can use the rule for the auto scale also. You can do the scaling with the rule, and we can use the Azure monitor rules to scale based on the performance metrics. So you can do the auto scaling based on the performance metrics. Just you need to define the scale out or the in conditions. For example, scale out when CPU is greater than the 80%, for 10 minutes. Just scale it out, or the scale it in when the demand drops. Likewise, we can put the conditions. So this ensures your app is always responsive and the cost efficient. Another feature is a zone redundancy and the high availability. You can deploy your application in the different zone for the high availability. If one zone fails, then the another will be up and running. So your application will not be down. The premium V3 and the isolated V2 plan supports the zone redundant app service and the environments JRASE with the SLA up to 99.99%. So you just need to deploy your applications across the multiple zones in the region. So this ensures the high availability even in the event of the regional features. So if you deploy into the America zone and the Europe zone and the Asia zone, if the one zone, one region got the failure, then still your applications will be up and running. The other is your logging and the monitoring for this Azure has, and the file system, blob storage, Azure monitor and the application insight, HTTP request logging, diagnostic logs, Azure monitor and the snapshot debugger for the deep analysis. So smart detection, log analytics, workspace. So these tools helps maintain the application performance and the availability. So app setting and the configurations is another features that Azure portal gives. The app setting and connection is string we can put into the settings, the features via the app configuration that I will demo later. Let's just move to the other features. So for the performance and the load testing also, we can do your application's performance and the load testing. It has an integration with the Azure load testing. You can do the stress test before go live. Additionally, additionally, you can use with the App Insight to analyze the bottlenecks. Beside this, it has a containerization support. Azure App Service has a containerization support. It can run the Docker containers from the Docker Hub, Azure Containers Registry, and the local Docker file. So it has a full Linux support also, and the CI/CD with GitHub and the Azure webhooks. For security features, it includes the managed TLS, SSL, private endpoint access, VNet integrations, IP restrictions, DDoS protections, web applications, firewall, WAF with the app gateway. So this security ensures your applications meets the enterprise grade security requirement. So now let's go to the Azure. Just we created the app service and explore the features. Let's go to home. So we just created this the software conference demo app service. So we can go and check here. So we have a activity log here, so we can see the once the application is deployed. Now we haven't deployed anything in this app service, but once we deploy, we can see the activity log. We can manage the access control, and we have a tags also we can add. If we need a tag, we can add a later also, that's not a problem. We just added the two while creating this app. So it has a Microsoft Defender for cloud, diagnostic, and the solve problems, events. This events is in the preview, log stream. So for the deployment, we can manage the different slots. For example, we can add the slots for the we can add the slot for the developments, UAT, and the productions, and deploy the code into the this slot. And whenever we need, we can just swap up the code with each other and fix sometimes the issue. Also, we have a deployment center. So we can select the source for the deployments, and we can, if we want to do enable the deployment center using the GitHub, Bitbucket, local Git, or the Azure repos, and other manual push, those we can configure from here. So if we select the GitHub, then we have to authorize and sign in, and then we can provide the organization's repository and the branch name. For setting and the performance, so we can set the application settings value from here. For example, so we can add the application settings value, app name, theme, or the any configurations that we need. We can add from the here, and we can add those for the different slot. For the developments, the setting value can be the different, and for the production or the live, it can be the different. So according to the slot, also we can add the settings value and configure from here. And beside this, we can add the connection string here. We can add the connection string for the blob storage or the database connection string, anything we can put here. For configurations, also we can set up from the here. So even I created this for the .NET. Now we can change into the another stack and the another versions. That's the configuration we can change. For authentications, we can use the built-in authentications. So for example, if I click the add identity provider, then we can select the identity provider, such as we can use the Microsoft, Apple, Facebook, GitHub, and the Google, Twitter, and so many other options. We can do the identity, and also we have a backup planning. Also we can do, if we need a custom domains, we have this custom domains, and the certificates for networking. This is also the here. And for scale up and the scale out, we have options here that also we can do after creating the app service, and based on our application need we can do all those settings. For API management also, there is a there are a lot of features and the functionality that I cannot demonstrate everything in this session, so I'll just quickly run. And for performance also, we can monitor the load testing and developer tools, clone console, those things are here. So there are a lot of features. For API, we have a API management. If we need to integrate with the different API, and we have a separate API applications, and we need a central management systems. For that, we can use the API management, and we can just move from the one API need to call the another API of the another service. Then those things also we can manage from the API management perspective. For monitoring and the app insight, we have here, we can see the alert metrics and the app insight also here. So this all about the demo. Now let's go back to the slide. So now let's summarize the developers' benefits of using the Azure App Service. App Service has a seamless DevOps integrations. It supports for the CLI, PowerShell, Bicep, and the low operational overhead. And we can scale from the free tier to the production grade apps, and we can integrate with the GitHub code space and the Visual Studio. With that, we have a lot of other features and the functionality that I already mentioned and the demonstrate in the demo. So for the best practices, I would recommend to use the deployment slots, integrates with the key Azure key vaults for the secrets management, such as the connection string, API key, password, and the some confidential informations. We can use the integration with the Azure key vault that's there for the confidential management. We can use auto scaling for the performance, as well as we can set up the CI/CD pipelines early, so we will not have the deployment issue and the deployment headache, and the manual tasks of the deployment. So we don't need to do if we set up the CI/CD pipelines early in the Azure App Service. Beside this, we can enable the diagnostic and the logging, so that we can just monitor our applications. And we can use the Defender for the app service, that also I would recommend to use. That's all for the presentation and demonstration. Thank you. I hope you have found these sessions valuable. Now I would like to hear from you any questions, queries.
Perfect. Let's take some questions. You want to grab a glass of water because you have been speaking for non-stop.
Yeah.
Okay, so I'm going to remove your screen and let's take one from Nestor. Nestor has joined us from Chile and he's asking, is there code and security review? Can it work with Azure DevOps?
Sorry.
There's a question on the screen. It
Uh,
says, Nestor is
is it
asking,
good
is there code and security
security review?
review? And can it work with Azure DevOps?
Yeah, actually, I already mentioned and demonstrated there are some security options that it works, and we can do the configurations from the application app service.
Mhm.
And the for code and the review also, the infrastructure guide that can write those, and we can run into the app service.
Perfect.
We can deploy
There's
that
another question.
security code. Yes.
Okay, perfect. There's another question coming from Nikita. I don't know. I think when you were giving a demo, that is when it was asked. It is beyond just enabling them, you can get it. What are the key architectural decisions to make when using Azure availability zones and app service to maximize the resilience? I think when you were giving a demo, that's when she asked it.
Okay. Actually, for this, we need to use the zone redundancy plan, and we have to deploy into the different zone with the different multiple regions. So the one zone goes down, then the another zone will be up and running. So that's the way to handle the downtime of the application.
That's true. That's true. And there's a gentleman commenting that yes, it works perfectly with DevSecOps. Yes, Azure App Services works seamlessly with Azure DevOps or DevSecOps, whatever you want to call it. It works absolutely fine with that. Now, let's take one from Sakshi. You know, that we have quite a few questions. I don't think so we can take all of them. But Sakshi is asking, how does auto healing in Azure App Service work, and can it be used as a primary resilience mechanism?
Yeah, for auto scaling and the auto healing, that we have auto scaling and the scale out and the scale in features that we can work that scales based on your application needs. Sometimes if the CPU's usage is more than 80% and the traffic is above the this, then scale it to the certain level. Those we can do and add conditions there.
I know what is auto scaling, but what is auto healing?
Healing,
Did you talk about
don't
auto?
know.
auto
Auto scaling, I talked about the auto scaling.
yeah, I don't know
Yeah.
what is auto healing. Sakshi, it will be nice to know what is auto healing. Perhaps you
Healing, yeah,
wanted to say
healing.
scaling, right? Yeah, I
Yes,
think.
maybe.
Yeah. Well, I thought, okay, let's take one more from Vidhi. It's what are the key difference between Azure App Service built-in feature for high availability and implementing a multi-region deployment with Azure Front Door? I have never heard about Azure Front Door, to be honest.
Azure Founder, actually, Microsoft in May 31st, Microsoft just removed some the availability and this backup plan. So for that,
Mm-hmm.
we can use the Azure Front Door. That's the
Oh,
way that we can secure the applications and the downtime also.
oh, I see. I didn't know about
So
Azure has
that's
Front Door.
Azure Front Door just we can use and deploy the application into the multiple region.
Oh, that's good to know. All right, I would just use Terraform or something like Bicep or on.
Yeah, actually, I have one article in the CSharpCorner about
Yeah.
the high availability of the Azure App Service using the front door.
Oh
So there
wow,
is a detailed explanation. Yeah.
All right. Okay. Okay. Let's take maybe one more. Right? Is there anything else coming? It says high availability will be retired soon. That's so sad. We need high availability, right? Okay. How
Yeah.
we
Um,
need
for
it.
that, we have to use the Azure front door actually.
Oh, it's a new concept, right?
Yes.
It's a new service, right? Mm.
Not a new, but that's the
Mm.
concept we have to
Okay.
implement there.
Okay. You can definitely tell that me and people in the comments are not as expert as you are. Okay. So let's take a question from Hemant. He's asking, how does Azure handle scaling in a serverless environment?
So I just demonstrate in the demo there is
Hmm.
a scaling option, scale out and the scale in. So the serverless environment doesn't mean it's a serverless actually. I mean, the server is handled by the Microsoft and the Azure.
Mm.
So they will take care of the servers and they have given the facility to the scale in and the scale out. So we can use that facility.
Yeah, and one thing to note, right, when scaling up, right, what if 10 million people end up visiting your serverless platform, right? What is it? What if it really scales to sky? What
Yeah,
happens then?
sometimes that problem can come. I heard that the one organization set up the auto scale and
Yeah.
uh, it went to so off that they need to shut down their company because they have to bill a huge amount to the Microsoft because of that auto scaling feature enabled.
Yeah, I think
Yeah, sometimes
I
that
don't
can
know.
happen. Yeah, we have
Yeah,
to be
I don't
more
know about the
careful about
portal.
this.
But in AWS, right? I think it must be also in Azure. When you create these virtual VPCs, virtual private computers, and you can put all your resources, and when it is auto scalable, even in
Mhm.
auto scalable, you can put up a break that okay, you scale only up to 5 VMs or up to this. You
Yeah,
do not scale more than that. I
yeah.
think it must be
So
there in Azure also.
it is there, but when
Yeah.
applying those rules, we have to be more concerned and yeah, more focused. We have to think more carefully.
All right, that is it. I know it's late in Nepal, so almost like 8 p.m. It's dinner time. Satya, thank you so much for joining. Any final thing
Thank
you want to
you.
plug before we let you go?
Thank you, Simon and the CSharpCorner for providing opportunity, and thank you all the attendees. If you have any questions, concerns, you can connect with me in the LinkedIn, or you can comment there. I will reply there. Yeah, that's all.
Then,
Thank
all
you.
right. Thank you so
Good
much,
evening,
Satya. Have a nice
everyone.
evening, and see ya. Bye bye. Thank you.
Bye bye.
All right, ladies and gentlemen, that was about serverless and Azure web apps. Quite a few questions, so we cannot take all of them. But we'll now move to the next session. But I think we have about some time. What time is it? Let me check it. We have about 4 minutes, and the next speaker is not there. Hooray! It always, it always makes me nervous when when the speaker who's speaking, that speaker is finishing, and the next speaker is not there. So I'm always worried that whether I will be ghosted or what. So never mind. We'll take a minute break, right? And then we will be back. Enjoy the conference.
Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on 4 powerful pillars: the Sharp platform, bringing Web 2 to Web 3; the Sharp token, fueling growth and rewards; the Sharp Rewards app, where you learn, earn, and grow; and the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth. Own your future.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Hi everyone, and welcome back to the Software Architecture Conference. We now move to the third session of the day on the day 3 of Software Architecture Conference. The next speaker we have is Abhijit Das. He's a solution architect at TCS. I think we have not really hosted a lot of folks from TCS at our virtual conferences, so it's really good to have him, right? Someone from India. He's going to talk about, I always mess up this word. It's a tongue twister for me. Observability for application using GenAI. Abhijit, welcome to the Software Architecture Conference. How are you doing today?
Yeah, I'm doing good. How are you?
I'm doing absolutely good, Abhijit. Thank you so much for accepting the invitation. I know it is almost dinner time here in India, right? So I won't take much of your time. Please feel free to go ahead and share your screen. At the bottom of your screen, you'll find a plus icon. Click on it, share screen, and then you can select your entire window, and then we can get started.
Sure.
By the way, are you in Calcutta?
Yes, I'm in Calcutta.
Oh, perfect. No surprises.
So,
All right. I see
is
you're
my
inside the
screen
StreamYard.
visible?
Yeah, you're inside the StreamYard. Once you move to your slides or something, I'll then add it to the stream.
Sure. Yeah. So,
Yeah, I see your
yeah.
slides, and you can see a pop-up that says StreamYard is sharing your stream. Next to stop sharing, there's a small hide link. Maybe you want to
Yes.
click on it. Once you click on it, it will go away.
Yeah.
Perfect. Everybody else can see your screen, Abhijit, and next 30 minutes is all yours.
Sure. Shall I start?
Yes. Yes.
Yeah. Hello, everyone. So today I'm going to present and share my experience uh, with respect to observability for the GenAI system. So that is one of the major ask what we are seeing across the different customers, what we are having. And as GenAI is the uh, widely accepted and widely people try to transform their self, and there are different applications, the capability what GenAI is having, they wants to use that one. And in that perspective, they are started using different customers, they started using. But the problem is when they are using that as part of the production environment, they are ready to use into the production environment. At the time they want to understand, okay, the GenAI application, the different LLMs what I'm going to use, so how it will affect my reliability of the system. So that's where this particular thing is coming to picture, and we are seeing a lot of customers are interested in this area. And that's where I want to share one of the implementation what we have done for global financial service company. So I was there a solution architect and looking for the platform engineering side, where the SRE is the main topic. So how can we make a system more reliable? So that's where the customer has came to us and told that, okay, you have done an observability for our different types of applications. Uh, so now we have introduced GenAI as part of our application, different features. So how can we uh, consolidate as a whole? We can observe that GenAI models as well as the application, and how do you do that? And if any issues will come, and whatever issues we are facing right now, which is including hallucination, including latency spikes, so all those things, how can we observe and give me more data so that I can go and quickly uh, use those data to make it to resolve those incident much faster way. Okay, so that is the kinds of a statement what they are giving to us. So then we are talking to different stakeholders, let's say ML engineers, we have talked to the application developer, the different security team we have discussed. And then we try to understand that how can we bring that particular capability into our observability framework what we all are already having into the customer world with respect to the observability. So that's where we have brought few layers on the existing observability framework. uh, so those layers, addition of those layers will bring that additional data which is required from the LLM into the existing observability framework. Okay, so that is the thing, that is a case what we are looking into to the observability. Now to do that, there are two major thing we are, or major challenges we are facing. One is the security part. So how can we observe certain data with security, uh, so that there are no PII data or certain secret data will not be available towards us when we are observing. So that is the security part is one of the major thing. And the second thing is the hallucination, what customers are when they are training certain models, LLM models, so they are also hallucinating. So to to handle that particular thing, MCP protocol is one of the thing what we have adapted, that one. So before going into deep, like how we have used that MCP protocol, I want to just explain that what it is. So MCP protocol is a way, a protocol through which two parties will be able to communicate. Now here, why it is special? Because before MCP protocol, people used to use different types of methods to do the communication between the different data sources and the LLM models. Now there is no common way to use that one, but this particular protocol will help us to generally get all the data sources in a similar manner to the available towards the solution or the system whatever you have. In that case, let's say if you have an AI application, so MCP protocol will be able to provide you certain data from certain tools or data sources into your application. So here we are trying to build a system where we are trying to get certain data from different sources. Okay, so that's where the MCP protocol will be able to help us. Okay, so if we see at the right hand side very quickly that MCP host will have that application which is using internally the LLM, and there has to be certain MCP client has to be written which will be connected to the respective MCP servers. Now MCP servers will act as a different data source. It can also act as different tools. Okay, so what is happening is if you want to bring certain data from that particular tool or data source into your application, then at the part of MCP server you can put certain guardrails to protect that particular data. Let's say PII data you have into that particular data source, so you can mask things which you do not want to expose to the application or to the LLM into the MCP server space. So that is one of the security feature it will bring into the picture. And then the application, once it gets the data, then it will send it to the respective LLM and it will do the respective work which I'm going to tell you in the upcoming slides. But yeah, more or less we have used that MCP protocol, and from MCP protocol we also collected the data. So in the next slides we will be able to upcoming slides we will be able to see that. So what is our goal, main goal to implement that observability is whatever app is there that is going to prompt something, and that particular prompt is fed to the respective model, and from that model we'll get the response. So that chain we need to observe, we need to collect as much as data possible, so that from that data we will be able to debug certain issue, whatever issue will come. Okay, so that is one of the major goal what we have. Next is the different monitoring matrices. How can we monitor different matrices with respect to latency, with respect to failures, the drifts for the models. Okay, so those are the things that monitoring also one of the major goal. The third thing is the prompt anomaly and hallucination, as I mentioned. So as customers are trying to train their on-premise LLM with the different types of prompts, the data or the output what they're getting is often often hallucinating. Okay, hallucinating means the data it will repeat and it will not give the correct output what is expected for a given input data. Okay, so this is the two things which is very important, and that is the major uh, blocker what customers are getting, and they try to understand how to resolve it first, how to detect it, and then how to resolve it. Okay, so that is one of the thing. And the next thing is the visualization of the GenAI reliability. So how it is. Okay, so how can we visualize what are the different matrices? How can we infer that one? So those are the things. So these are the major 4 points what we are trying to resolve and reach that particular thing, that how to take that. Moving forward, so this is a very high level architecture. I try to make it available over here. So at the left hand side, if you see that from the application perspective, it will have the user interfaces. Okay, it will have it should have the logging SDKs, and then there has to be certain there has to be model context protocol, and from that layer we are trying to get the data. Okay, using open telemetry. So here we are using open telemetry. So through open telemetry we will be able to collect that melt data, which is metrics, event logs, and traces, and then from that source we will get the data, respective data, and we will be storing the data into the respective different tools. So here as an example, the different matrices we are storing in Prometheus, the logs and all it is stored in Loki, and the traces we are storing it as a Tempo. Now with the help of these three type of data, we are generating the respective visualization and analytics as part of the Grafana dashboard. Okay, so this is a very simplistic diagram I'm trying to put it over here. Okay, so moving forward, so now there are many matrices we have configured as part of the dashboard, but here I'm trying to put some of the important matrices which can be helpful, and how it looks and what are the things it will be able to help. So for example, we have created a prompt latency dashboard. Okay, so where at the right hand side you can see we are collecting different types of prompt. So there are different types of prompt which can be present. First is zero shot prompt. It can be zero shot prompt, which is like you need not to give any type of input, okay, to get the certain output from the LLM. Okay, so that is the zero shot. Okay, so for that zero shot prompts, what are the different types of output we are getting, and from that what are the latency we are getting, means the LLM is how much time that LLM is taking to respond on that zero shot prompt. So that is one of the time chart we are trying to get. Okay, next is the few shot prompt, so where we have to put certain words and tokens and give it to the respective LLM, and how much time that LLM is taking when we are giving few shot prompt. So like that, with zero shot, few shot, chain of thought, tree of thought, okay, iterative prompting. So with respect to this individual prompt, what is the time that particular LLM, whatever we are training, that it is giving response. So that is like, this is like for one LLM, what is the different response time for a particular type of prompt. Okay, so this is one of the type of graph we are taking. So from here we will be able to understand that what are the different types of prompt we are giving, and from that whatever output we are that particular LLM is giving, what are the different outliers. Okay, so from the outlier we will be able to understand that, okay, this is different types of output which we may not be expecting. Okay, so that particular anomaly or outlier detection we will be able to do from this particular graph. Okay, so that is one of the very important graph which is required to understand the prompt, the latency of the particular LLM. Then another important metrics is the hallucination heat map. So here we are trying to analyze that if there are different models are there, when there are different models are there, and we are giving a certain prompt and it is giving the response. Okay, so now we are collecting the user feedback that whether that particular thing is hallucinating or not. Okay, so with respect to that we are trying to get certain percentage, that how many percentage of people are saying that let's say LLM model 1, which is and version 1 for a particular prompt, how much negative feedback we are getting from for that particular model. Okay, so like that we are collecting the percentage that how much hallucination that particular model is having and getting, and what is the different models which are getting more accurate. Okay, so towards that we are trying to collect the data and check the heat map, and based on that we will be able to understand, okay, this is the particular model where we need to do more improvement onto that particular model version. Okay, so that is a very important part to hallucination. But on top of that there is many other parameter. So this is the heat map. So other parameters, let's say for example hallucination score. Okay, how can we calculate the hallucination score? So in that case there are different other matrices we are collecting. Let's say for example perplexity is one of the matrices through which we will be able to understand, okay, if we give a particular set of prompt, then what are the different words it is taking and generating, and what are the different priorities it is setting with respect to the upcoming words. So if the perplexity is more, then it is more tend to go towards the hallucination. If the perplexity value is less, then definitely it will be more towards the definitive part of it, and it will probably it will less hallucinate. Okay, so like that there are other matrices like engram map is there, that is edit distance is there. So there are multiple matrices we use to understand the model performance, and based on that we try to calculate the hallucination score. And obviously, to rectify that one, we collect this particular hallucination heat map as a human in the loop concept. Also, there are other methods we have used, let's say another LLM as a judge for this particular hallucination to understand, because there are multiple applications which is used into the customer world, where there are no very less amount of people who are able to give the feedback. Okay, so that's where the LLM, another LLM will come into picture. So yeah, so there are different methods we have used to make it more perfect. Yes, we are still doing that one, evolving and more maturing that particular any models what we have. So these are the things. And another very important part is the tracing, which is also very much required to do the debugging for a particular incident if we get. So in this part, we are collecting, as it is a telemetry, open telemetry data, we are collecting the respective trace IDs, timestamp, different application ID which are using that particular LLM. Okay, different request ID, LLM providers, error type. Okay, so here I am showing the error type 5xx. So there are other error types also like 4xx and all. So with respect to that, if we are trying to get that what is the error message, so we will get that. And once we click the trace ID, it will be able to show the entire flow, that what are the different stages it has gone to, what are the different spans are there. So in that respect, this is also one of the important metrics we are showing as part of the dashboard to help to understand and monitor and debug the issue from this. Okay, now, moving forward, there are few more matrices we have collected, which includes the hallucination score, as I mentioned, context mismatch, which is very obvious, and then the embedding drift. Okay, which is very important metrics apart from the latency, apart from the 5xx count and hallucination score. Okay, so these are the some of the matrices. Now, let's say that here I'm trying to make you understand that, for example, there is an application and we have implemented the observability. So how it actually works. Okay, so here if we can see that in the this is an app which is actually using the LLM models, let's say, and a user is doing a query to that particular app. Okay, now that query, it is not necessarily that it has to be through a chat interface, but it can be any other part also. But let's say that is a query. Okay, whatever user is doing towards the app. So the flow what is in general it is taking is, once the query came to the application, it will be able to after that it will collect all the different data sources and tools with the help of MCP. So that's where the beauty of MCP. And there can be data sources, there can be different tools, there can be data sources which are isolated, there can be tools which are isolated, there can be tools which are internally connecting to the internet and further collect certain data from the internet. So let's say APIs and all. So there are different types of data sources and tools are available. So what this app is doing is, one, it is getting the query, it will try to collect the respective data from the different data sources and tool using that MCP protocol. Okay, so it will get the respective context. Okay, so once it is get the context, it will mix the respective query and the context together and send it to the respective LLM. Okay, so once it is giving to the LLM, so LLM is having the uh, respective context, it is getting the respective context and the query. So that is how, based on that, it will respond towards the app. Okay, based on the context. So that is where the retrieval from the data sources and tools, then it will augment inside the app, and then it will send it to the LLM, and LLM will generate that particular output. Okay, so that is the RAG, a typical RAG I'm talking about. So this is one of the scenario, but to explain, it will be important. So now, while this particular thing is happening to solve a particular user journey, or to go through a particular user journey, from this app, we are tracing all the data using OpenTelemetry. Okay, so that's where that observability things will come into picture. So before LLM, also the applications are, means the data are collected through OpenTelemetry from the app. So there will not be a very drastic change across the different setup. So that is why this particular solution, so we'll add certain layers. Okay, so once the tracing is happening into the open telemetry, obviously it will generate certain spans, trace IDs, and different types of data it will generate. Now once it collects the data into the open telemetry, we can see what it will do is, in this short, in this small box, if you can see, so first is the root span. Okay, so once the user does the query, okay, so it will create a span called, let's say, handle user query. Okay, so now once it is starting the handle user query span, after that it has to prepare the data or augment the, retrieve the data and augment the data. Okay, so that's where the second layer of span, which is a child span of this particular root span, will be created. Let's say prepare LLM request. Okay, so that is the second level or child span of that particular root span. Okay, so once it is done, then it will again call this particular LLM to generate the respective data. Okay, so in that case, when it is doing that, then it is like, let's say, LLM inference, which is the again child of this particular child span. Okay, so like that, there are different span level information we are collecting through open telemetry data, open telemetry from the application. Now once we collect that, we are storing the traces as part of the tempo tool. Okay, so once that particular tempo tool is once the data is there available into the tempo tool, that will be visualized as part of the table what I have shown earlier. Okay, so this is the typical traceability part with respect to different layers we are doing with the help of open telemetry. But here I am focusing only on the GenAI part. But yes, there are UI, there are other backends, there are API calls, there are databases, there are so many layers. But here I am focusing on this particular LLM and generative AI part only. Okay, so now let's say, for example, how that will be able to help us to resolve an incident example. So there is an example, there is an incident, let's say, where we are getting alert, like we receive that, okay, there is a prompt latency. Okay, and hallucination score is getting higher. Okay, after an LLM model is upgraded. Okay, so that is the incident we are getting. Okay, so in that case, what we did is we go to that particular dashboard. Okay, and we can see that prompt embedding drift is getting spiked. Okay, so that from there we are going to the respective traces. Okay, and from there we will be able to get the context. So once we get the data from that particular traces, and traces, that particular trace will be having all the list of events what occurred in sequence, and from there we are able to collect the respective error, that what particular error is happening, or what are the different things are happening into that particular thing. And then we try to do the model engineer prompt engineering fix. Let's say, for example, it can be any, it can be like the prompt list of prompts, whatever you have given, whatever prompt template is used, that can be not correctly given. Let's say, for example, it could be it is like direct, and direct prompt it is used rather than chain of thought. So we have updated or upgraded that type of prompt as a chain of thought instead of traditional prompt one-to-one derivation. Okay, as part of the training data, prompt training data. So instead of traditional prompt, we are converting it into the let's say chain of thought prompt template. Okay, there are context truncation logic that also can be updated. So that can be different actions which we can take. Okay, so this particular observability will be able to help us to give an end-to-end view. Okay, and from there we can directly go to the respective trace, and we can resolve and derive the respective solutions. Okay, so what we are able to achieve in last 6 months is this: we are able to get a full observability, not for obvious, not for all applications, but yeah, focused one or two application. It is like one application, under that there are different services. So one application, so full observability. uh, so that is one of the thing, uh, through which we will be able to deep dive into and pinpoint the particular problem what it is. So that is one of the thing. MTTR with respect to GenAI related issues, that is reduced huge, because previously it was like GenAI LLM is kinds of a black box. Okay, so that's where the problem is. So now once this observability framework is implemented, the MTTR reduction is huge. The prompt level diagnosis that we are able to do, root cause identification, so that is one of the important thing. Hallucination reduction, that is also one of the thing, because we are getting less number of hallucination complaints from the respective users. And then the feedback loop is one of the thing, through which you can see that in the previous incident what we are talking about. So there we are able to understand that okay, it is a prompt related issue. So that's where the feedback loop is much faster, became much faster. So that is these are the major improvement or benefit we are getting once we have done the observability framework. So challenges, there are many challenges. So these are some of the challenges what we have faced, where the most important is the hallucination detection. So that was the major thing. So that is one of the major achievement I can see we have achieved into this particular project. So hallucination detection signals, so that is major thing. Obviously the lack of standards observability, that is thing. So now we have implemented the telemetry, open telemetry, and there are certain standards we have implemented. So that is one of the thing. Also there are high variability of prompt outcome. So that is also one of the thing. And last is the data privacy and security concerns. So different stakeholders are concerned about the LLM, that how my security will be maintained if we use the LLM and GenAI. So that is also one of the thing we are uh, try to address. Okay. And here the MCP protocol will help us a lot to address that particular issue. And the distributed tracing with the help and latency breakdown. So this is also one of the major thing we are able to achieve over here. So yeah, these are the challenges and the respective mitigation. There are many other challenges, but these are the, I thought these are the major challenges which I should be telling you, because yeah, everybody will face this challenge while doing the observability for a GenAI application. So what are the things we learned? First is the in GenAI, there are multi-dimension thing. There are different things where we have to consider different layers, where we are trying to understand that we should not be creating a new observability framework for the GenAI, but rather how can we implement the GenAI observability into the existing observability framework. So that is one of the thing. So multidimensional it is. Next is the model context protocol. As I mentioned, it is a key thing for traceability. And then another thing is the collaboration. Obviously it is required. So we are part of the SRE team and the platform team, so where we are promoting the collaboration between dev and ops and how can we collaborate. But here as the GenAI comes into picture, we have to bring another one, who is the uh, machine learning part, who are mostly engaged with the business side of thing, business side of part. But yes, the ML engineers also will be are very important in this particular journey. And then the dashboard, main thing is in dashboard, when we are setting up certain alerts, setting up certain threshold, so we have to focus like all the alerts has to be actionable. It should get certain insight that what are the different why that particular threshold and what are the different errors has occurred into which system. So yeah, it is not just about the visualization, but how can we convert that visualization into action. Okay, so yeah, these are the lesson learned. So yeah.
Absolutely amazing, Abhijit. I love the pace and all the things that you shared. I think it all comes from you working with clients and the projects. So thank you for sharing all the practical, experiences. I think everybody in the audience was they must have really loved it. And I see there are a lot of questions, but we have time, right? So after your session, we have time. So let's take a few. Take a few of those.
Sure.
Starting with the first one. I think it was, when did we start? Okay, I think this one from Rohit is asking, how do you handle the security and privacy of a sensitive data that might be present in the logs of an LLM application?
Correct, correct. So that is a very important question, because that is the very common questions across the customers, because they are generating a lot of data. It is not only just the secret, but the lot of other data, other business logics, business insight also they are generating. So how can we restrict that one? So first thing is, we are not using the uh, LLM as an API. So that is
Okay,
first thing. We
yeah.
are promoting the on-premise LLM. So that is one of the major thing. Second thing is MCP protocol. So that helps us a lot. So uh, MCP protocol, if you can remember, as part of this slide also. So there actually it is like client server fashion. It is implemented, and wherever is the data source. Okay, let's say there is a secret. Okay, but we need to get the context out of it, but not the data. So that's where we'll put the MCP server in front of it, and into that MCP server we'll put the guardrails. Okay, so let's say we understand, okay, these can be the secret patterns, let's say, and we don't want to expose that one. So those kinds of guardrail we can put as part of the MCP server. So whatever MCP server is returning to the respective MCP client, so at that time it is already guardrailed into the MCP server level. So into the MCP client level where the application exists, that will not get the secrets but the context. Okay, so that is the major part where are we have resolved that particular security part. And yeah, that helps stakeholders understood, yes, our data is safe, and then yeah, we move
So
forward.
Abhijit, I'm really curious, right? When you say that, don't consider your LLM as an API, you put it on your on premises or an edge devices, right? So are you suggesting I take a GPT-4 and put it on my devices on premises? Is that what you're suggesting? Am I getting it right?
Yes, yes,
Oh, geez, what
correct.
would be the size of it?
Okay, so now we are getting into the architecture. So
Yeah.
so the thing is, it is not like that entire LLM you are taking into your organization,
Hmm.
and then you are using it and sharing it. So there is a uh, agentic concept where there are different small contextual LLMs we are having, which are which are having specific actions to perform. Okay,
Oh, I
so
see.
those are the small LLMs which are containerized. Okay, and put as part of you can consider it as a sidecar as part of the
Yeah.
application. So that will be used instead of that entire LLM you put it into a large system and entire organization is using. That is not practical. Okay, so
Yeah.
if that kind of scenario you need, it will be obviously the APIs call. But yeah, as as I'm from the banking domain, so there it is strictly no. So yeah, so that is
That's
also
good.
one of the things.
Thanks for answering it so detailed, Abhijit. Let's take one from, I think it's
Sure.
from Nestor. Nestor is asking, in the app use aspect-oriented programming for
Mhm.
for logging and observability, I think it should be, is the app use AOP?
Okay.
I don't know what is the question. Do you get it actually? What is the question
Uh,
here?
is that all or something? I'm
You,
explaining
you can
something.
come back to StreamYard. You can see the screen. You can come back to StreamYard. Are you inside the StreamYard? You can come back and see this question on your screen.
Okay. is the app use AOP, aspect
Hmm.
oriented programming, for logging and observability. I'm sorry, I do not get that
Me neither.
particular acronym and meaning.
Yeah.
Yeah,
Never
I'm
mind. Never
sorry.
mind. Next time, maybe you can explain us what do you mean by AOP. We'll take another question by Sarthak, right? Sarthak
Mhm.
Varshan is asking, what is the performance overhead of the MCP, and how do you balance rich data capture with its impact on LLM response latency?
Okay. So, yeah. So performance overhead. Uh, we are really not getting a performance overhead as such, but it is like the latency graph I was talking about. There are different types of prompt, so it is always based on the prompt how we are training. Because if you do a lot of training, if you are pushing a lot of training data, lots of prompt into the particular LLM, it is increasing its size, okay, and it is exponential, okay. So in that perspective, we are getting, like, if you put certain prompts into certain format, the particular latency will increase, but over time, if we do it properly, it will also decrease also latency, okay. That always not depend on let's say underlying hardware, which we are thinking always, but it is not always the hardware. There are different aspects also, that how particular prompt you are engineered, okay. So it depends on the respective use case and how you are using that output into your particular program, so it also depends on that. So your prompt template matters a lot based on your application part. So yes, the performance, it is adjusted, and it is mostly the ML engineers who are focusing on that, that how can they fine tune that particular thing. But yes, from the observability perspective, we are able to get as much as data as possible, because we have the MCP, the secrets are guarded, and we get the respective context absolutely fine. And then if we feed to the respective LLM, which is already trained with the other prompt, then we'll get the correct information and data.
Abhijit, it is so good to see, like companies like TCS, and they're very big in India, right? They are onto
Yes.
so much of edge tech. I thought, we are still at, maybe like .NET 4, or maybe some things like that, Java. But look at you, you're talking about MCPs, you're talking about agents, you're talking about LLMs on edge devices. It is so good to see, you all are working on so much latest tech. Let's take one more question. I think then we'll move to the next session. That is by Kansing, and he's asking you your personal opinion. Is what is the biggest challenge you faced in standardizing log collection from both containerized and non-containerized application for a unified view? It's a good question.
Yeah. Okay. Uh,
I just don't look at
uh,
logs.
so yeah, standardization actually, it does not depend on the architecture. So uh, it is mostly the technology what you are using, and that comes under the SRE and DevOps perspective. So that's where we are templatizing the different logs. We set the standards from the enterprise architecture perspective, and whether it is a containerized or non-containerized, it will collect the data as part of the open telemetry, and it will put and store into the respective tools and all.
Yeah, I also love open telemetry. I've been starting
Yes.
using only like from last year. One of the speaker was talking about open telemetry. I went back, I implemented it, and it really helps to see what's happening in
Correct.
your applications. It is very good.
Correct.
I see Scott is saying great session, Abhijit. Sarthak is saying this is amazing. Thank you so much for sharing your knowledge. Hemant Nestor says thanks for the session. Very good, interesting. Hemant says
Thank
great
you.
perspective. Looks like people really loved your session, Abhijit. I know it's 8:30
Thank
p.m. in India and it's dinner time. I won't take any more time. Any final thing you want to plug in before we move to the next session?
uh, yeah. So yeah. So if you have any questions, you can reach out to me. I have my email ID. I'm available in LinkedIn. So yeah, let's connect and
Great,
we can
Abhijit.
discuss.
Thank you so much. Thank you so much for accepting the invitation. And we hope to see you in the other conferences that we do.
Sure.
Thank you.
Yeah.
See
Have a
ya. Bye
nice day.
bye. Well, ladies and gentlemen, that was Abhijit for you, and it's time, ladies and gentlemen, it's time we welcome the hero from the developers community. He is none other than Tural. He's a software architect, lead software engineer, Microsoft MVP, CSharpCorner MVP, public speaker, author, blogger, YouTuber. He's a trainer. He sells his courses in Udemy, and more on top of that, I've started to realize that he has been going to gym a lot these days. So he's also a bodybuilder. Ladies and gentlemen, let's have Tural, who's going to talk about cloud native microservices and architecture in practice. Tural, welcome to the Software Architecture Conference, man.
Hey man, hey buddy, how's it going?
It's going good. What happened to your background? Are you not in your usual room?
Yeah, I'm in a different place. I'm in a different
Yeah.
place. That's why the lighting is a bit problematic right now. Sorry
Hmm.
about that, but I'll do my best to present cloud
Yeah,
native
it's good. At least you're
microservices
carrying
in practice.
your mic, right? You're carrying your mic everywhere, so that is good. All right, buddy. Please feel free to go ahead and share screen, and then we can get
Uh,
started.
Thank you very much. Thank you very much, buddy. So let me share my screen. Oh, wow, wow, wow. Okay. So ladies and gentlemen, today I'm going to talk about cloud native microservices in practice. I haven't prepared any presentation. I have just two images to show, and then we'll switch directly the code because I really love directly switching to the implementation rather than talking about the theoretical stuff. Of course, theory is really important, but behind the scenes, you should understand how the things are implemented, okay? So first of all, I want to talk about microservices itself. It will take only 2-3 minutes to give a high level view of microservices. Then we'll switch to our repository, to our implementation. Okay. So nowadays, as you know, it is about approximately 8-9 years people are actively using microservices. So what are the microservices? Microservices architecture helps us to build smaller services, independent services, and these services can live separately, can be maintained separately. They have separate databases, separate teams, separate language. They can fail independently, and that's why it is really easy for you to write your microservices in a different language. For example, one service you can use Go, and in another service you can use C#, PHP, etc., and that will help you to get most out of the programming language also. Okay, so depending from the language also, you can apply different architecture to your microservices. One microservice you can implement using clean architecture, another microservice service element you can use classical layered architecture, etc. So they are separately independent each other, and you can use different architectural parents to build your services. And the most important thing here is today I'm going to demonstrate how to write cloud native microservice. And also, as you know, I'm Microsoft MVP. That's why I'm a big fan of Microsoft in this case. And I really love cloud services from the Microsoft. And today we'll talk about Azure Cosmos DB, Azure Service Bus, Azure Table Storage, Azure Functions, and I will show you the practical cases where you can use these different cloud services. Okay, so before that, I want to mention that you can get our source code from github.com Tural Suleymani. Just go to Tural Suleymani. And here we have Activity Analytics Microservices app. You can also see we have all these presentation files, images here, and all the detailed information about this microservice, how you can run it. And also per service, you will find a lot of interesting information. For example, when you switch to tracking service, even for tracking service, you will have a separate, let's say, a README documentation file about the packages used, key features, the project structure, and also the most important stuff about the cloud, why we selected Azure Cosmos DB, why table storage, etc. I think this will help you to have even broader information about the developed application. So let's open our Visual Studio. and let's talk about microservices. But before that, let's try to understand in a brief manner how our microservices developed. So the main purpose here is I have developed a small application. This is a bit far away from the production code, truth be told, but this will give you a good understanding of microservices development. So the purpose here is we have multi-tenant application, and for multi-tenant application, we have analytics module. This analytics module by itself consists of multiple services, which we call microservices. They are independent services. They communicate with each other using loosely coupled communications, event-based communication like the service bus, etc. Here we have a bit buggy case where I use the Azure table storage to directly bring information for our dashboard API, but in some cases it is applicable. But in a best case, your microservices, the database of your microservices should be isolated, because the database part of your microservice is the encapsulated unit of your microservice. If one microservice has access to another microservices database, in most cases it means, let's say your microservice is a class and you have direct access to encapsulated data. Okay, so in our analytics application, first of all, everything starts from the API gateway. I developed this API gateway here. This is an Ocelot. I really love working with Ocelot because it has all the possible features of default API gateway. You know that API gateway provides us a lot of interesting features, like rate limiting, caching functionality, authentication, authorization functionality, load balancing functionality. I did a bit small configuration here that I really love Ocelot because it works in a, let's say, configuration-based development. Yeah, it is really easy for you to configure all this stuff, and they have really cool documentation to get out of the most information from it. And these API gateways helps us to encapsulate access to our tracking service. So the main purpose of tracking service is to help us to write information about the some sort of statistics. For example, let's say we have millions of users. They selected one page to review. We want to grab more information about the statistics, how long they used our application, the statistics about different pages, statistics about provided services. That's why we have developed our tracking service. By the way, this whole application is one of the interview question for me to implement. One of the Sweden company asked me to develop such type of infrastructure for the interview process. That's why I bring it to the public, let's say, to help others also to build such type of structure, such type of application structure. So our tracking service, let's switch to our tracking service. By the way, as I mentioned, you can get the more information from the tracking service here. So this is our microservice designed to track user activity. Okay, we have different metrics which we can get from the tracking service. The purpose of tracking service is to encapsulate the logic of tracking user activity. So this is a classical layered architecture. So you see, I've used the classical layered architecture. If I have different sort of the complex microservice, I can use domain-driven design approach, the clean architecture, etc. So here we have basic tracking service, and when I go to implementation of it, you see it uses the Azure Service Bus. And first of all, let's see what we have here. We have some sort of queue to send metric information. For example, my queue name is user activity events. Of course, it would be better to take this information from the configuration rather than directly typing here. But for the easiest cases, you can just write it like a constant here. And here we are sending information to the service bus. So you see we have service bus here. And for the tracking service, I'm using Azure Cosmos DB. I really love Cosmos DB. But of course, all the services, all the technologies have their own pros and cons. In this case, Azure Cosmos DB is a bit problematic. But from the scaling perspective, from the high throughput extensibility perspective, this is really cool. I think this is Microsoft's flagman database to be used. And here you will find more information about Azure Cosmos DB. Why we picked Azure Cosmos DB? Because it has built-in global distribution. For example, if you have clients from different countries using Azure Cosmos DB, you can have global distribution. It will help you customers to get fast access to the database rather than you have customer in Japan and you are writing and reading data from the USA. And the system will allow you to globally distribute your database to near to Japan, for example, to Tokyo, in Tokyo, okay? It has high volume mechanism with low latency writes. It is really fast to write data. It is really fast to read data. And from the scaling perspective, Azure Cosmos DB has built-in feature that will help you to extend your database and scale your database from the horizontal perspective. Okay, not vertical, but horizontal perspective. And Azure Cosmos DB is NoSQL database. You don't need to sync on the foreign keys, the complex table communication between the elements. You have just the JSON information. You can use the graph-based data. You can use JSON. You can use key value and column family data models in your database. This is really cool, I think. And also Azure Cosmos DB supports SQL-like query capabilities. It has some limitations, but anyway, for the basic usage, I think this is cool. But if you don't like Azure Cosmos DB, you can pick alternatives like Apache Cassandra, Amazon DynamoDB, Google Bigtable, etc. Okay. And here, what we are doing in our application when we get a response from the user, first we will trigger our tracking controller, and this tracking controller will trigger our tracking service. The responsibility of tracking service using a user activity repository to store information in our Azure Cosmos DB. We may fail to send data to Azure Service Bus. That's why we are storing our data like in a reserved copy in our Azure Cosmos DB. And also you can build another small application to get some sort of additional statistics from your Azure Cosmos DB. So you see we have Cosmos DB user activity repository, and we have database containers, and we are creating and storing information in our Azure Cosmos DB. And on the other hand, the service's responsibility is to treat our service bus. This is really important. And we are sending, let's say, one reserved copy of this information to our service bus. Let me show you. Just a second. Azure Service Bus. Why? Because I want to have communication between my tracking service and my aggregation service. The responsibility of tracking service is to send data to Azure Service Bus, and our aggregation service will grab information like it is a simple consumer. Okay, this is our producer, this is our consumer. Our consumer will get information from Azure Service Bus and will aggregate it. That's why it is called aggregation analytics service. So tracking services responsibility is to get data from user as fast as possible, but it is not responsible for aggregating data. In a microservice environment, every microservice has its own responsibility. And aggregation service, it is Azure function, the service Azure function. And this Azure function's responsibility is to take information from service bus. Service bus acts like an architectural mediator between your microservices. Okay, this is a loosely coupled communication between microservices, asynchronous based communication, because when you need to add additional services to here, you don't need to inject them to tracking service to make communication between them. So if you want to isolate your microservices, we usually use asynchronous based communication like message brokers. One of them is going to be our Azure Service Bus. Of course, you can use another message queue, message broker system. But in our case, we are talking about cloud technology. That's why I've used Azure Service Bus. And let's go to, so We understand what's going on in our tracking service. We also understand the Azure Service Bus responsibility. And the main stuff here, the main building block of our application is going to be our aggregation service. So aggregation service is just Azure function. So what is the purpose of Azure function? Long story short, it is just like in your application's background service. Yeah, you have some sort of background service. The responsibility of background service is to do something in a background. You can act your Azure functions like a background service. When you have something in your Azure Service Bus, your Azure function, you can configure Azure function using different styles. You can differently trig this. And one of them is going to be Azure function is going to be your consumer. In this case, if you have something in your service bus, this will pull information from here, okay? And in this case, we have, you see, it was a bit tricky to inject all this stuff, so I used a bit different approach. Because I'm using the static constructor, etc., but they are not important for now. So we have the simple function name here. You can use attribute-based development to give a better name for your functions. And here we have, you see, we have service bus trigger. Service bus trigger, as you remember in our previous code, we used the queue name called user activity events, okay? So when there is something in the queue, in this queue, this Azure function will be automatically triggered, okay? And we have some sort of log writing. This is not important, but the most important stuff here is we are starting to process user activity. So we have process user activity event asynchronously. This is a separate class which will help us to build the main building block, the main logic of our application. So you have plain data in your tracking service, plain data, millions, billions of data. And your aggregation service connects to Azure Service Bus to take this plain data, plain text information, and to aggregate them to get some sort of statistics, okay? This is the main purpose of aggregation service. So you say we have page view, we have login. Of course, you can get out of this if else's using the different, let's say, high cohesion loosely coupling techniques plus some design patterns. And we have separate methods for event types. For example, if we want to get user activities based on the page view, we'll trigger this function. If a login-based activity, will trigger this function, okay? And if these functionalities are dynamically changing, of course, it would be better to refactor this feature. But right now we have only two features. So that's complete, okay? So what we are doing here, we are doing some manual stuff. We are getting data from the service bus. We are trying to somehow format it like an ATL. Yes, so you have some sort of data, you're aggregating it. This also can be done by Apache Kafka. But anyway, so we have some sort of aggregation. We are doing some for each here and trying to get most out of this data to build aggregated data and store it in our Azure Table Storage. Azure Table Storage is cheap rather than Azure Cosmos DB. You can think of it like a limited Azure Cosmos DB. Azure Cosmos DB has more features than Azure Table Storage, but for not complex data, let's say it like this, you can easily use Azure Table Storage. That's why, for example, you have millions of data, you are aggregating it to reach, let's say, hundreds, thousands of data. You have just aggregated data, okay? You will not do additional operations over this data. That's the data is a final data in our Azure Table Storage. So that's why I've used Azure Table Storage. For plain text, for some sort of complex operations, I can use Azure Cosmos DB, but I know that this is the final one. So table storage will be enough because it doesn't have the complex data aggregation stored in a table, okay? After storing data in a table storage, you can't do so much complex operations over it. And yes, we aggregated data and we stored our data in our Azure table storage. Let's go to our code here. So you see, let's talk about the configuration. You will use Azure data tables. This is our table client. Of course, first of all, I want to mention that I should mention it before, but it is not important if you are using the Azure or AWS or Google Cloud stuff. The important stuff here is you should be able to calculate cloud costs also. This is another skills you need when you work with cloud. Just picking some cloud service, okay, I really love Azure Cosmos DB, let's build everything on it. So this is also not an option. And almost all cloud service providers like Amazon, Microsoft, they provide the similar services. For example, you have Aurora database, you have the Cosmos DB, they are providing the same type of stuff with different prices, let's say. And the most important stuff here is to understand, for example, in the cloud, you have multiple database models, okay? SQL-based models, non-SQL based models, and you need first to do some sort of calculation to understand which database you need. You may need NoSQL, you may need relational database. So having cloud doesn't mean that, okay, let's use NoSQL everywhere. That's not true. You will use SQL, you will use NoSQL, and you need to understand, you must understand the pros and cons of using different database models in case, for example, Azure Cosmos DB or table storage, which one to use. Yeah, Azure Cosmos DB has a lot of features, but do you actually need all these features, or maybe the table storage will be enough for you? So in this case, the table storage for us is enough. So we installed our NuGet packages. Let's go to the dependencies. We have packages. So you see we have Azure data tables. Microsoft Azure Cosmos is for Cosmos DB. Here we have Azure data tables, and we have table client. I haven't developed this classes from scratch. This is Microsoft provided built-in classes. I have just injected them, and at the end, when I aggregate data, I'm just calling table storage to store data, like in a classical development style. You're doing some sort of if else's the logic and then storing the data. Okay, cool. From the microservice perspective, I really want to talk also about these different instances. So in a microservice development, it is not just enough to write a code. It is, you need to understand the system design. You need to understand the scaling points of your application, because only bounded context doesn't make the decision of creating microservices. Okay, yeah, we divide the huge picture into bounded contexts, and we pick one bounded context to match to one microservice. But in some cases, even in this bounded context, you have additional bounded context, not bounded context, but subdomains. And that's why one bounded context can match to multiple microservices, depending from the scaling, depending from the load perspective. Okay, let's say for the tracking service, you said tracking service is deployed in one server, and every server has its own limits, and you cannot in an infinite manner to expand and vertical scale of your devices. Of course, cloud also provides such type of possibility. For example, in AWS, you have 24 gigabyte of memory usage in a classical manner, but you should focus on horizontal scaling. In this case, if we have too much load to our tracking service plus our aggregation service, Azure will take care of course, you need to configure it, but you will not anything manually, and depending from the load, system will instantiate a new instance for you. For example, if we have high load to our aggregation service, to our tracking service, the cloud will take care of getting another instance, hosting it, and parallelize the load. Okay, for example, 10,000 requests. Okay, let's create another instance. Then we have 5,000 requests per server. And this microservices is also a good unit for you to scale out your application. And we have scaling points here, tracking service and aggregation service here. Okay. And the last one here is going to be our Azure table storage, because my dashboard API, which is going to be, think of it like open telemetry, or think of it like Grafana type of application. Okay, we have this API. Let me open this API here. We have dashboard service. We have dashboard controller, and you see dashboard controller directly uses our table storage. Okay, so it is a bit means that we have the same database for different microservices. Of course, we always try to separate databases for our microservices. It would be better to just stream data here to the another message broker, and the dashboard API will be able to pick data and represent it. But anyway, for the storage based approach, I think this should be okay. So we have Azure table storage here, and we are just retrieving data from the table storage. You see, in a monolith application, what you are doing, you are going to build everything in one single application. And when you build one single application, the application is going to grow vertically, okay, not horizontally, vertically. And when you broke something, the entire application breaks. So that's why our microservice architecture will help you to scale your application independently, to develop your elements, modules independently, to host them independently, and even to let them fail independently. That means when entire tracking service fails, aggregation service still continue working, because it doesn't depend from the tracking service. We have mediator here, which isolates us from the tracking service. Okay, and yeah, let's switch to our dashboard client. This dashboard API, I didn't develop the service stuff. Of course, it would be better to write like in our tracking service to create a service, but when things are easy, you can avoid service layer, because I don't think that it will help you much in this case, because you don't have special business logic. You're just grabbing information from database and you are just representing this data. So you see, we have page view statistics information, we have login statistics information, and we have the general overview here, which helps us to take information from the different ones. Well, yeah, in this presentation, I didn't talk about the observability, and this is another important stuff of microservices, of course, but for 30 minutes presentation, I think that would be okay. And again, just a small reminder, go to the github.com Tural Suleymani, and you will find our activity analytics microservice. And also don't forget to store it if you like it. So this is our activity analytics microservice. Just download, run it, just experiment. Of course, you need Azure account first of all. Just open. Microsoft provides a free account for you, and also these configurations will not take let's say, the huge amount of money, charge a huge amount of money. This is just an experiment microservice. Just run it and experiment to learn the microservice stuff, because this is really, really important in modern days software development. Well, overall, that's all. Yeah, I think there is nothing for me to share right now. I'm just stopping my presentation. Stop.
All right, that's a very good and crisp presentation, Tural. I also love the sessions that are only demo, right? So I'm also a big fan, or also everybody here in CSharpCorner. We all are developers, so anybody who's talk about the code, we all love it. We have quite a few questions, right? Let's start from the first one. It is
Thank
by
you. Yeah.
Rohit Tomar. He's asking, how do you ensure strong data isolation between tenants at the database level when sharing resources to keep costs down? It's a complex question.
Yeah. Thank you very much for the question, Rohit. So as I mentioned, in a database level, you need to first understand which database model you are going to use. You should define if you are using relational model or non-relational model, like NoSQL database model. And after that, you should do some sort of calculation. You should get some sort of metrics, and you can understand these metrics doing some talking with your domain experts. Or if you have old applications, you can just grab some metrics from this old application, and this will help you to understand which actually cloud service database you need. Okay, you may need Cosmos DB, as I mentioned, table storage, other storage mechanisms, and even selecting Cosmos DB or table storage will help you to keep costs down. For example, table storage is a bit cheaper than Azure Cosmos DB. Yeah, data isolation. How do you ensure strong data isolation? Yeah, you can just use the tenant ID based partitioning key. In Azure Cosmos DB, you have default partition key feature, and mostly we select tenant ID for partitions. And in Azure Cosmos DB, you have physical and logical partitioning. And per partition, if I remember correctly, you have 20 gigabyte of size. Okay, for example, you define that your one company is one tenant in your case. This is a classical one. And for this tenant, you can store 20 gigabyte of information. Okay, so I think this should be enough for you to handle all this stuff.
Yeah, 20 gigs is good enough for a database. And you're right, Azure Cosmos DB can be really expensive sometimes. Right,
Yeah.
you've also faced
Always
it.
you need to monitor all this stuff in cloud, just not to fall in love with cloud and use all this service.
Now there's another question coming from Vidhi, and Vidhi is asking, could you elaborate on the security measures you put in a place to prevent a noisy neighbor from impacting the performance or security of other tenants?
Yeah, that's also another interesting question. So security, I think I can divide microservices into three parts. The microservice development itself, which I demonstrated today. Observability monitoring, you can write entire book on it. And the third and the most important book is going to be security. There are tons of security stuff, and mostly I worked as an engineer, not focused on DevOps stuff to take care of microservice security, but usually you are using OpenAPI or GBT tokens to have in a classical, in an easy way, you have API gateway, you are using authorization over it, and using the GBT token or OpenID, you are taking care of securing your microservices. And also deploying them in a Kubernetes is also another challengeable stuff, which you can also provide the private network, let's say, between your microservices and using VPN stuff, etc. Yeah.
Perfect. Thank you for answering that. We'll take one final question and then we'll wrap up this session. And it is by Nikita. She's asking, what are the key architectural decisions you made to handle the unpredictable and often spiky data ingestion patterns from multiple tenants?
For multiple tenants, yeah. For architectural decisions, of course, I would say that before choosing, you should start everything from scratch, okay? So before choosing your microservices design, you should make sure that this even microservice design is best for you, because for 2-5 developers, choosing microservice development is not the best approach. Maybe you can go for with monolith first or modular monolith. I really love modular monolith. For the last 2 years, people started to speak more about modular monolith. I can say that in 60-70% of development, you can get rid of microservices and bring modular monolith to the table to use it, because everything has its own pros and cons. And from the architectural perspective, designing all these microservices is also another challengeable, problematic process. Even working with famous companies, I realized that defining microservices is really complex, and the business processes are changing often. And for example, we started with in this case, we started with one microservice, and 6 months later, we divided it into 3 microservices.
Wow.
So the architectural decisions actually depends from the business also. The unpredictable stuff will be always on the table. So as a software developer, your solution, your agile approach should to detect this unpredictable stuff fast and apply it to your architecture.
Amazing. Thank you so much, Tural, for that. We have a Sarthak says, absolutely amazing content. Thank you for sharing your knowledge. And we have Scott. Scott also commented in the past that, great session, Tural. I'm your student from Apache Udemy course also.
Thank you very much,
So
Scott.
you have brought some of your fans here. All right, Tural, that is absolutely good. I know it's getting late at your place. Any final thing you want to add before we move to the next session?
Yeah, just one thing. Thank you very much for the invitation. And don't forget to let Mahesh Bhai to give another MVP for us.
Well, I will put in a good word for you. All right, Tural, take good care of yourself, right? Have a great evening, and thank you so much once again.
Thank you very much. Thank you very much for having me.
Thank you.
Have a nice
Bye-bye.
day, guys. Bye. Bye.
All right, ladies and gentlemen, that was Tural for you. And now we move to our next session. We have a couple of minutes. Let's just take a quick commercial break and we will be back. Where's the video?
Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on 4 powerful pillars. The Sharp platform, bringing Web2 to Web3. The Sharp token, fueling growth and rewards. The Sharp Rewards app, where you learn, earn, and grow. And the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
All right, everyone, welcome back to the Software Architecture Conference. We now move to our next session, that is by Vitali. Vitali is going to talk about from startup chaos to enterprise scale, a QA journey through hypergrowth and acquisition. And Vitali is a senior QA engineer. Hi, Vitali, and welcome to the Software Architecture Conference.
Hello, Simon. I'm ready to tell my
Yeah,
story.
you're ready. Where are you joining us today from, actually?
Don't know. Sorry.
Okay, all right, never mind. So what you can do is you can... Yes.
Yeah, currently, I'm from Georgia, the country.
Oh, Georgia. I mean, is it somewhere in Middle East, right? No?
Yeah, it's on the border between Europe and Asia. It's near
yeah,
the
many
Turkey.
of my friends living in Dubai, I think they go to Georgia for holidays or something for vacation.
Yeah, it's a popular place, Batumi, to have a like vacations, maybe a few days trip. It's very
It is still
popular.
not a part of EU, right? Is it a part of EU?
Yeah, not a part of EU yet.
Oh,
But
perfect. Great.
they're
So,
looking forward.
yeah. All right, Vitali, please feel free to go ahead and share your screen, right? At the bottom, you'll find a plus icon. You can click on it, share screen, and then you can select your screen or window, whatever you wish.
There is not much to share because I have only text about my notes, which I will talk in. But if someone prefer to read, I can share my notes.
Well, it's up to you. If you just want to speak out, it is absolutely okay.
Okay, let's try with speaking up.
All right.
Without
Next 30
there are
minutes
no
is all yours
special
then.
slides. Sorry.
The stage is all yours.
Great. Okay. So my name is Vitali Shchur, and I'm honored to speak with you today. We'll talk about QA journey through real-world challenges, growing pains, and strategic milestones. All drawn from my perspective. It is my experience at Perimeter 81. When I joined, we were a small startup of about 25 people. And fast forward a few years, and we are now backed by Checkpoint Corporation for 100 millions, like $500 million, huge amount of money. And today, the company is approaching 500 employees, tens of thousands of customers, and we are just entered the Gartner Magic Quadrant, SaaS Magic Quadrant, which is a huge deal. It will allow. I will try to share just to show you this quadrant. Okay, image share screen. Share window or screen. I can't allow. Zoom entire screen. Okay, entire screen. Oh, should be there. So this is the Magic Quadrant from Gartner. Many companies are making their decisions on which services are buy based on the Gartner reports. And we are entering it starting from niche player, which anyway is a huge deal. And we are near the giants like Palo Alto Networks, Fortinet, Netscope, Zscaler. So this is a great achievement. And we spend only like 5 years maybe to climb this high. I'm very proud of it and happy for the company. So this isn't just a success story. It's a story about how QA matured with the product, how testing practices are evolved during hypergrowth, and how we are integrated into global cybersecurity enterprise without losing our agility. First, the number one selling point of Perimeter 81 was Zero Trust Network Access. And now we are growing to sell SASE, SASE, Secure Access Service Edge. It is a cloud-based network architecture that converge networking and security services into a unified platform. It combines SD-WAN, so software-defined wide area networking, with various cloud-native security functions like secure web gateways, cloud access security brokers, firewall as a service, and zero trust network access as well. This integration provides secure and optimized access to applications and resources, regardless of user locations or device. It was very in time when the COVID was strike. So let me begin with a story from very early days of the company, even before I come here. So we have just launched our first landing page to attract customers. It looked great on macOS. It was reviewed by developers and by some managers, but only on MacBooks. No one thought to test it on Windows. And after the publishing, we waited for traffic to convert, but conversion was far below expectations. Eventually, someone checked the landing page on Windows browser and discovered that critical UI elements weren't working. The user couldn't sign up, they couldn't buy anything. So we have effectively locked out our huge part of our audience. That failure didn't just hurt marketing, it delayed growth. But more importantly, it became a wake-up call. At that point, we didn't have a QA, but this incident made it clear someone has to own quality. And while it was too early to hire full-time QA, we started with a part-time tester, working just a few hours a day. And yes, it made a big difference even at that minimal level. So next, I would want to tell about shifting from B2C to B2B, how our QA was scaled. The Perimeter 81 was grown from B2C startup Safer VPN, which aimed to sell the quality VPN service to end users. And with time, we moved to B2B strategy. As we transitioned from B2C to B2B, expectations were changed drastically. Corporate clients demanded higher reliability, real security compliance, professional onboarding, and fast issue resolution. And as always, zero bugs in the product. We realized that the lack of normal QA was holding us back. So in 2019, the startup hired our first full-time QA engineer, and likely that was me. And what I walked into was exactly what you might expect in a fast-moving startup. Documentation were spread across Slack, U-Track, and random Google Docs and emails. Test cases were stored in Google Sheets. There were no unified test tracking system, no version control for test documentation. I spent my first week reverse engineering the system to understand the fragmented knowledge base and trying to map out the product logic and to understand it. Then I asked a simple question: do we have a budget for a real test management system? Fortunately, the answer was yes, and I've conducted a short market comparison based on price, popularity, integration options. In the past, I have used tools like HP Quality Center, Zephyr, TestRail, and I ended up with recommending TestRail. And we adopted it quickly. First, it was in trial mode, and I've showed it to the management that it is working fine, and every tester should be happy with it, and the managers will get the transparency. When we adopted it, it gave us a centralized test suite, traceability history of execution, of test changes, and the great visibility for both managers and testers. And I've kept in mind that in the future, when we will introduce the automation testing, the TestRail is really fine at working with it and translating the automation results into the test runs presented in TestRail. Let's speak about tools to make or break our growth. Early in our journey, we used U-Track by JetBrains as our project management and bug tracking tool. It worked for a while, but then we ran into some issues with like working in a few tabs at the moment, browser tabs at the moment. As the team grows, it becomes limiting, unfortunately. Eventually, we migrated to Jira, a painful but necessary process. However, this move came with a price. After around a year, when we moved into the Jira, we lost access to our original issues history. And they were like, I believe, around 2 years long. It was thousands of issues. But it's not a huge loss, but it taught us something important. Choose your tools with a scale in mind. Every system migration is a risk, not just technically, but in terms of lost knowledge. If you're building something with long-term potential in mind, please pick the industry standards early as only it's possible. Almost every corporate-grade tool have its trial mode or some limited functionality and small pricing mode. Like as far as I know, the Jira is totally free. If you use it for the project, not more than 10 with not more than 10 employees. Now we move to the rise of automation on our project. As our project matured, the number of test cases exploded because the complexity is rising exponentially with every new added feature. On the Agent side, it was about 500 test cases. On the platform side, it was far beyond 1,000, maybe even more. I don't know for sure because I was mostly responsible for the Agent side. Manual testing was no longer scalable. The Agent application full regression was taking around 2 weeks to me, and we were not available. We can't do it for every release, and the releases were frequent. Often they were like one in a week if we done this with some hotfixes. So of course, I've prioritized the test cases, and for the short releases, we perform only the smoke test, the critical and high priority tests, like so-called acceptance testing. And with that, we moved into the internal testing when the agent was tested inside our company, and then we rolled out this version to the small group of the customers. And if the work was fine, it was working fine, we rolled out it to all the customers. So time was come to started implementing automation, and on the early start, we ensured that automated test results were reported directly into test trail, which give us the real-time visibility, full traceability, historical trend analysis, and the visibility for managers, how the product quality is going, how the process of testing going. Automation wasn't just a performance booster, it allowed us to free up manual QA to focus on most valuable things: exploratory testing, edge case validation, strategic test design, and for tricky bugs investigations. One of the most complex features that we launched in startup times was device posture check, so-called DPC. It allowed our system to check if antivirus software was running on our user devices before granting access to users to sign in into Agent and into our VPN to give them access to the corporate resources. There were also a lot of other factors that the device posture check could test, like which certificates are presented in system, what is the system version, is hard disk drive encrypted or not, and so on. It sounds simple to implement such a feature, but in reality, it means that we need to research how to detect antiviruses on Windows, macOS, and Linux, like 3 major desktop systems that were supported in this time. And I was researching for 3 of them, all of them. We need to install and uninstall dozens of antivirus products for every operation system. We need to find the trial versions or contact the sales departments of this antivirus and telling them why we need some version for free. And need to read in technical documentations, reverse engineer behaviors, need to find the login signatures and verifications methods to detect these antiviruses and other things. It was a massive manual effort, and I was responsible for the entire initiative, and it was successful. The feature became a huge success among enterprise customers. They saw it as a true security value add, and it helped to drive serious sales. Growing the QA team strategically. The next part is about growing the QA team strategically. Here is something that I learned in time when I was working in Primitive81 in its startup phase, that team structure should reflect product maturity. When you are in early startup mode, you need to hire only experienced QA professionals. You need people who can build processes, create structure, and challenge assumptions. The people who know the best practices and can describe why they need to be implemented and how to do the things better, how to do things the best. In general, you need to make things as good as it only possible, because in the end, the things will be not perfect. But if you all the time trying to make them as best as possible, these bad things would not affect our product and processes too much. So once the team is more stable and you have like a few testers at least, you can bring in mid-level testers to scale execution. They already have some experience. They can learn the product with minimal intervention and minimal help from the experienced testers. And well, the product is mature and well documented. Only this time, that's when it makes sense to bring in junior QA engineers, train them, and let them grow with your product. But above all, if you want true scalability, you need to invest in automation engineers. They will multiply your coverage and let your manual testers focus on what matters most. Next part is about from startup to corporation, merging with Checkpoint. When and what challenges we meet. When we were acquired by Checkpoint, we were about 250 employees. Now our division is around 500 employees. So we continue our growth and investment in this product, and this is great. Surprisingly, at first, not much was changed. We continued using our tools and processes. We keep our internal culture and workflows, but over time, as integration deepened, we started adopting Checkpoint's internal systems, especially for security and access management. Bureaucracy grew a bit to getting permissions, working with help desk, onboarding. Started to took a bit more time, but it's okay. It's a price that we expect to pay. From a startup perspective, this felt a bit heavy, but from a security perspective, it made perfect sense. The Swiss cheese model of security tells us that every extra layer of security reduces the risk of catastrophic failure. And in cybersecurity area, which we are working from the beginning, this is non-negotiable. Despite increased procedures, our productivity didn't suffer because we had solid foundation and motivated people. Regarding the tools, the checkpoint in checkpoint we continue using Jira. We are moved from TeamCity. We moved to GitHub Actions. We continue using the Confluence by Atlassian. First, we're trying to switch to Microsoft Teams as a main messenger, but now it is like our auxiliary messenger, and the main messenger still the Slack because it is most this is most suitable for our needs. So next part is about final lessons for high growth teams. If you're a startup or thinking about scaling one, there are some takeaways. Have QA from day one, even part-time. Bugs don't wait for budget approvals. And the dedicated QA, even part-time, will save you a lot of efforts. Document everything. Even if it is messy, even if it's just Google Docs or emails, or maybe some long posts in Messenger like Slack, you need to write it down, not hope that you will remember everything, how anything should work, and how the decisions was made. Just write it down. And of course, the better to write it down in one place. This will save you later when you will move for some knowledge base tracker like Confluence. You will be able to just import all this text. Don't scatter your knowledge across Slack. You'll forget with why certain decisions were made, and you'll suffer for it. And it would be impossible to find these decision-making process and texts in the Slack across multiple chats. Pick scalable tools early because it will help you to avoid migrations unless they become absolutely necessary. For example, as I talked before, we were trying to migrate to Teams Messenger, but it wasn't absolutely necessary, so we keep using Slack. It is secure. We have our Microsoft SSO single sign-on in it, so it's pretty mature, corporate level, great messenger. And always keep security in a mindset. All ad layers, even if they seem redundant, there will come a day when some of these layers will save you and you will don't even know. And your QA team is your growth enabler. Empower them, scale them wisely, and they will protect both your product and your reputation in time of growing and gaining customer user base. To wrap up, the evolving of QA at Perimeter 81 is a mirror of our company growth. From a chaotic, fast-moving startup, we successfully moving to a stable, scalable, and secure enterprise. And QA has played a central role, a major role in every step. I wish every startup to have a great business idea, to have great salesmen, and to have experienced such a explosive growth as Perimeter 81 has experienced, and successful buyback or moving into corporation. And I wish every startup to successfully go through this painful phase when you are changing, like metamorphosis from startup into corporation. Not every company are good with it. Not every company does it successfully, but we are happy And all this because our employees who know how the things should be done, not only in startup, but in the enterprise as well. And this helps us a lot. Thank you so much for listening. I hope this session has given you some practical insights, some realistic expectations, and a bit of inspiration for your own journey, where you are on the startup to enterprise path or not. And I'm happy to answer a question. Please feel free to ask in anything.
Thank you. Yeah, there are a few questions, Vitali, and thank you so much for that fantastic this fantastic session. All your experiences, quality is definitely it's very important. And let's take a few questions from the chats that we have. It's coming first from Hemant, and he's asking, what was the single most impactful QA strategy or tool you introduced that helped the team scale from 25 to 250?
The 25 to 2050 employees, it's a whole company. The QA at the moment, I believe, like maybe 30 people, and we had a relatively small amount of QA to all of the company, because we have a lot of salesmen, salesperson, and developers, and so on. At the moment, I'm working for like 4 or 5 developers, and this is not the ratio you will meet in Microsoft, where I have heard that sometime it was like 2 QAs for every one developer.
Wow.
The most, because they have a huge product and a lot of tests, I believe, because Windows is a big system. So the most impactful strategy was, I didn't talk about it before, the simple prioritization. If you have prioritized correctly your steps, you can in 2 hours perform a smoke test and report to your manager if the build is viable or not. In 1 day or 2 days, you can perform acceptance test and say that this product shouldn't have, I can't guarantee it, but 99.99% that there wouldn't be any blocker bugs, and 99.9 no critical issues. And then if you continue for like 2 weeks with a full regression, you can guarantee that there will be no medium severity bugs in the agent, in the product. So this prioritization was helped us a lot, but it is like general knowledge how to test. The tools I've mentioned, moving to the correct test tracker, using virtual machines to test on different operation system versions. For Windows, people were lucky because they have like Windows 10, Windows 11 in recent times. For macOS, Apple is supporting 3 past versions of macOS and 1 upcoming. Like for 3 or 4 months, you have public beta where you need to test that nothing was broke with new like security additions. And we have that experience that new macOS version broke our feature, so-called automatic Wi-Fi security. It wasn't major issues, but it was like one of the selling points. Thank you.
Perfect, Vitali. Let's take one more question and then we'll wrap up the session. There's a question, this is an interesting one, where Nikita is asking, can you share an example of a time when the lack of dedicated QA caused a major issue in the early startup days and how you eventually solved it?
Yeah, great question. Thank you. There were critical bugs in Agent. But likely, I've just caught them, and we saved our customers from facing it themselves. And they were caught because I've introduced one of the first things that I've done was introducing testing on virtual machines to test on the older versions of macOSs, and it helps a lot. That's like early startup days.
That's perfect. So I think that is it. That is all time we have to take the questions, Vitali. I know it's evening at your place, so you may want to go and have some dinner or something. Any final thing you want to add? How can people get connected with you? Are you on LinkedIn? Are you on Twitter? How people can connect with you?
You can write me in LinkedIn, I believe. I'm open.
Okay, perhaps I think yeah, I'll find your LinkedIn maybe, right, and drop it in the comments so that folks watching they can get in touch with you. Thank you so much, Vitali.
I can write it maybe in the
Yeah, you
chat.
can give it in the private chat, and I can pick it up from there.
Okay, I will try to write it. Just a minute.
No problem.
Okay, connect to command, connect. I need to sign in with.
Now you can just give it in the private chat here on the right hand side. I can copy paste.
Oh, I see. Yeah, writing in the private.
Yeah, I'm gonna copy it and give it in the comment, and everybody can actually go ahead and connect with you. Thank you so much, Vitali. Thank you so much for sharing your pearls of wisdom. It was so good to hear your success story. Right. We hope we get to host you in the upcoming events. And yeah, have a lovely evening.
You too. Have a great evening. Bye.
Thank you. All right, ladies and gentlemen, what a lovely success story to hear about QA and how important it can be. I would really go back and replay this to my team members and tell them on how important QA can be. We now move to our next session, and next session is actually by Alexander. If I'm not wrong, is that how he says his name? I don't know. There's a language. It's called Alexander. Perhaps that's how he says it. Unfortunately, this is not a live session. This is going to be a recorded one, and it's a very short and crisp session for just about 9 to 10 minutes. And it's about API first core banking system, engineering for security, scalability, and compliance. Please enjoy this quick short session, and then we have a surprise session coming for you all.
Good afternoon. I'm Alexander Potapenko, and today we'll see why API first banking is no longer just an idea. It's the standard banks must follow to stay safe, scalable, and fully compliant with fast-moving rules from FCA, DORA, MiCA, and FINMA. Most banks still run on one huge tightly coupled system, a monolith. When one piece fails, the whole thing stalls. Under the FCA new 24-hour impact tolerance rule, a full outage is not an option. UI DORA adds hefty fines if you can't prove resilience. So we need a different tech model, one built for failure, audit, and speed. Regulators are convergent. DORA demands operational resilience by January 2025. MiCA sets clear crypto custody duties. FINMA's 2023 Cyber Circular tighten cloud controls. All these frameworks ask for the same three things: clear APIs, strong audit trails, and fast recovery. API first architecture hits all three. API first means we write the interface contract first, usually an open API file. That contract defines how clients talk to each service. Then we build each service to honor the contract. This flips the old model. The API is not skin on top of a database. It's the core design driver. Because every call hits a secure gateway, gate, uniform auth, login, and rate limits. Teams work in parallel on well-defined services. New features drop in weeks, not months. And every request is logged and time-stamped. Perfect for audits. In practical terms, we break the big core into dozens of small services: payments, KYC, lending, crypto, etc. A single API gateway stands guard. If KYC gets slammed, payments still run. If lending needs an upgrade, we deploy it without touching the rest. If we will look through some actual cases, we could find that such guys like Scarlett used API first to launch a mobile bank in 4 months, quick enough to beat competitors. It now supports over 800,000 customers. That speed comes from clear APIs, not big bank releases. If we will talk about such newcomers like Finraise with product like CoreBank and Bitconto that allowed you to keep fiat money and crypto on the same ledger, what is compliant with MiCA's travel rule is automatic because every crypto event flows through the same audited APIs as fiat events. We are not locked to one vendor now. Mambu and Scarlett give us a plug-and-play software-as-a-service model. Third Machine lets you code custom products. Saskada bolts one as a modern ledger beside an old core so you can migrate to SaaS gradually. And only Toom and newcomer Finray lets you self-host. Mark these dates: 17th of January 2025, Dora Live. 31st of March 2025, FCA's 24-hour tolerance fully enforced. Even MiCA take its action from the end of 2025, and the MiCA license is required. FINMA's cloud guidance is live now. The clock is ticking. Microservices and new risks. Network hops and latency. Services must agree on data consistency, and partial failure is normal. We need retries, circuit breakers, and strong contracts. And good news, with proper design, failures are isolated, not systemic. To manage the complexity, we need deep visibility. Distributed tracing with Checker tells us how a request hops through services. Prometheus metrics show real-time health. Grafana dashboard turn raw numbers into clear traffic lights. API first doesn't erase risk, it reshapes it. You now guard many small doors, not one big door. Each endpoint needs scheme of validation, short-lived tokens, and positive security models. But breaches are easier to contain because domains are isolated. The hardest shift is people. The teams must become domain squads that own code to production. That needs DevOps, Git, and SRE skills. Upskilling or hiring is essential. Culture eats architecture for breakfast like in a strategy. So plan culture change early. In an event-sourced ledger, we need override. Each change is an event. Finance teams can replay history at any point. Great for audit. But it requires new reconciliation methods. The upside? Instant traceability, no silent data corruption. And if we are talking about possible best practice cases, we have to emphasize Write the API specification first. Enforce security at the gateway. Version every interface. Automate tests and rollbacks. Stream every event to secure log. Follow these, and DORA audits became routine. Once APIs and logs are in place, we can add intelligence. And now meet MCPI, a model that reads new laws overnight and checks if any API change breaks them. MCPI watches Prometheus metrics and predicts overloads hourly basis. It maps strange traffic flows and alerts. It even writes draft tests cases, reducing manual toil. API first delivers clear structure, speed, strong audit trails. And at the same time, MCP turns those trails into foresight, predictive compliance, and resilience. Together, they future-proof your core tech. Thank you for listening. API first give us the facts in real time. MCPI mechanisms makes those facts actionable. To be honest, I will be happy to answer your questions, requests, and it will be pleasant for me to help you with your journey. Thank you very much once more, and see you again.
Thank you for joining us today. I'm excited to talk with you about a powerful approach in modern software development, feature flagging. If you worked on a project where releasing new features involved some praying and cross fingers, you'll appreciate the control and flexibility that feature flagging brings. Today, we'll explore not only what feature flagging is, but also how it enables gradual rollouts and A/B testing, giving development teams the ability to release features in a smarter, safer, and more data-driven way. My name is Maxim, and I'm currently part of the engineering team at Google, where I focus on developing Android Auto to enhance user interaction by enabling smartphone projection onto supported vehicle displays. In my work, feature flagging, gradual rollouts, and A/B testing play a major role in helping us deliver new features safely and iteratively. I'm excited to share some insights and practical approaches to using these strategies, particularly in Java, that can make development both faster and more reliable. And before we dive into the details, let me briefly outline what we'll be covering in this session. We'll start by looking at the fundamentals. Then, I'll walk through some of the key benefits, especially in Java applications, gradual rollouts, and A/B testing. I'll share some practical tips on implementing A/B testing with feature flags, as well as metrics to keep in mind to get the most out of your test on my way through the presentation. And to round things out, we'll talk about best practices and some common challenges like handling security, managing technical debt, and ensuring that feature flags are used effectively without introducing complexity. Then let us start. And let's start with the basics. What exactly is feature flagging and why has it become such an important part of modern software development? Feature flagging, sometimes known as feature toggling or in some cases kill switches, is a development technique that allows us to enable or disable specific functionalities within an application without deploying new code. Essentially, it gives us the ability to control which features are visible to users through configuration settings rather than through code changes. At its core, feature flagging serves a few key purposes. First, controlled releases. It allows us to roll out features gradually, targeting specific user groups or regions, which reduces risk by letting us test features in production but with more limited exposure. Second, improves stability. which is always a top priority. And feature flags provide an added layer of control in production, allowing us to roll out features gradually, reduce potential risk, and quickly disable a feature if any issue arises. Third, experimentation. By using feature flags, we can experiment with new features, gather feedback, and make improvements based on real-time user interactions, helping us make data-driven decisions. And finally, faster development cycles. Feature flags decouple deployment from release. This means teams can deploy code even when certain features aren't fully available, as those features can be hidden behind a flag. Overall, feature flagging is a powerful tool for teams aiming to deliver stable, high-quality features more quickly with less risk. By giving us greater control over what and how features go live, we can iterate, experiment, and refine in ways that would be difficult to achieve with traditional release methods. Now, let's take a closer look at the benefits in Java. First, faster development and deployment in Java. Feature flags are highly comparable with Java's mature ecosystem, particularly in CI/CD and microservices. Java developers can integrate feature flags directly within frameworks like Spring Boot through conditional beans or through remote configuration, which makes it easier to toggle feature based on environment-specific properties or configuration servers. Additionally, Java's extensive support for dependency injection and modularity lets us easily manage feature and their configuration without extensive recording, making deployment faster and smoother. Moreover, it gives us improved stability for JVM-based services. Java applications often operate in a JVM environment where stability is paramount. Feature flags provide an extra stability layer for JVM-based services by letting us conditionally load classes or modules based on flag states. For example, we can use Spring or Micronode to set flags that control feature-related beans, enabling gradual rollout or selective rollbacks on specific server instances. And it gives us enhanced experimentation and A/B testing within the JVM ecosystem. Feature flags empower Java teams to implement experimentation at the JVM level, which is quite crucial. In summary, feature flagging in Java not only accelerates deployments and increases resilience, but also brings experimentation capabilities that are deeply integrated with Java's ecosystem. Now, let's a bit discuss gradual rollouts or partial rollouts and their advantages. Gradual rollouts are a feature flagging technique that lets us release new features incrementally, initially targeting only a subset of users. This strategy offers two key benefits: reduced risk and improved user feedback. Reduced risk. Gradual rollouts allow us to fine-tune the scope of a feature release, whether it's 5% or 10% or specific segments of users, providing a safety net for Java applications in production environments. We can manage rollout configurations at runtime, deploying features only to selected instances or user groups. By limiting the initial exposure, we can monitor for any potential issues, such as memory leaks or latency spikes, and check overall performance on a smaller scale before releasing the feature to a broader audience, and we can instantly disable the feature without any downtime. Then, improved user feedback. When we roll out features gradually, we capture valuable real-world feedback directly from early adopters. This detailed feedback is critical for identifying what's working, what needs adjustments, and whether any usability improvements should be made. Now that we've discussed the concept of gradual rollouts, let's look a bit at how to implement them in Java application. This involves using tools that support feature flagging and gradual rollouts, along with some practical code examples. There are several popular feature flagging tools compatible with Java that make it easier to set up and manage gradual rollouts. Tools like LaunchDarkly, Unleash, and FF4J provide robust support for gradual rollout with features like user segmentation, percentage-based targeting, and real-time flag management. Each of these tools lets us define feature flags set percentage rollout, and control which users see which features, all from a central dashboard. Now let's shortly take a look at some basic example on how to implement a gradual rollout with a percentage-based flag using FFOJ in Java. Suppose we have a new feature that we want to gradually roll out to users. Here's how we might set it up in code. Here we create a new feature and enable it for some percentage of users, like 30%. And with quite a flexibility, by passing a user ID to the context, we can evaluate each user individually for the new feature flag. To move further, let's explore another powerful application of feature flagging, A/B testing. Feature flags provide an ideal setup for running A/B tests, where we can test different versions of a feature on separate user groups, gather data, and make data-driven decisions based on real-world feedback. What is the purpose of A/B testing? A/B testing allows us to compare two or more variations of a feature to determine which one performs better. With feature flags, we can easily control which version of a feature each user group experiences. For example, let's say we're testing a new recommendation algorithm in our app. With A/B testing, half of the users can be shown the new algorithm, the B group, while the other half will update to a placebo version of the update to see the old one, the A group. This lets us evaluate if the new algorithm improves user engagement or satisfaction before fully rolling it out. Feature flags simplify this by letting us toggle features on and off or adjust them for specific user segments, making A/B testing more flexible, controlled, and scalable. Then, metric collection. After that, to make informed decision from an A/B test, we need to define and collect key metrics. Here are a few common ones. Conversion rate, measure whether user take a desired action like completing a purchase, signing up, and clicking a specific button. Engagement metric, track metrics such as time spent on a feature, page views, and interactions. Performance metrics. It's important to also track any technical metrics like load times, error rates, or memory usage. And finally, user satisfaction. Direct feedback from users can be incredibly valuable too. Some A/B tests may use surveys or feedback prompts to understand how users feel about the feature. In summary, A/B testing with feature flags allows us to release new features experimentally, collect meaningful data, and use the data to optimize the user experience. This data-driven approach ultimately leads to more successful and well-received product updates. Now that we understand the basic purpose of A/B testing and the key metrics we need to track, let's discuss how to implement A/B testing effectively using feature flags in your Java application. Here are some small practical tips and details for successful implementation. And the first one, define clear hypotheses and metrics. Before you even start your A/B test, it's essential to have a clear hypothesis. For example, if you are testing a new feature or UI change, your hypothesis might be the new design will increase user engagement by 10%. Once you have a clear hypothesis, you need to define the metrics that will help you measure success. This could include conversion rates, click-through rates, time spent on a page, or even user satisfaction ratings. Clear objectives will help you interpret the data correctly and ensure that you are testing for meaningful outcomes. Then, ensure proper user randomization. A key element of A/B testing is ensuring that users are randomly assigned to the A or B group so that external factors do not skew the result. As I already mentioned, many feature flagging tools like Darkly or FF4J allow you to easily manage randomized user assignments, but it's also possible to implement it manually. By assigning users randomly, you minimize bias and ensure that the result of your A/B test are reliably and statistically valid. Then, keep the test simple and isolated. When running A/B tests, it's important to keep the changes small and isolated to a specific feature or interaction. Avoid testing too many variables at once. For example, if you are testing a new algorithm, only focus on that algorithm's performance and not on other unrelated changes. This isolation will help you identify the direct impact of the feature you are testing. Now, monitor in real time. During the test, it's crucial to monitor how the feature behaves across groups in real time. Java feature flagging libraries and platforms often provide monitoring dashboards which can be used to track performance metrics like errors, crashes, and response times to identify any issues early on before the feature is fully rolled out to the entire user base. Then, ensure statistical significance. A common mistake in A/B testing is sending the test too early. You need to make sure that you've collected enough data to draw a meaningful conclusion. The size of your sample, the number of users in each group, is critical for statistical significance. Generally, you'll need a large enough sample to ensure that the results aren't just due to a chance. There are tools and platforms like Optimizely or A/B Testify that can help calculate the required sample size and ensure that your results are statistically valid. If you are manually implementing this in Java, you may need to track sample sizes and perform statistical analysis once the test concludes. Gradual rollout during testing. Since A/B testing often involves testing a new feature, you can combine it with gradual rollouts. This way, you can minimize the impact on your users. Start with a small percentage of users for both A and B groups and gradually increase the percentage as you collect more data and confirm that there are no major issues. Feature flagging tools like Launch Darkly allow you to control the user percentage that sees each variation, making this process easier to manage. And then post-test analysis and iteration. After completing the A/B test, you need to analyze the results carefully. It's also important to iterate. If the test results aren't clear, or if neither version performs better, it might be a sign that more changes or different variables need to be tested. A/B testing is not a one-time thing. It's part of an ongoing process of optimization. Feature flagging is a powerful tool, but like any technology, it comes with best practices and challenges that need to be managed carefully. In the next session, we'll go over some of key best practices to follow when using feature flags, as well as the common challenges that teams face. And first one, keep feature flags organized. If your system scales and you add more feature flags, it's easy for them to become unmanageable. To prevent this, maintain a clear naming convention and organize your feature flags based on their purpose. Then, remove flags as soon as possible. It's critical to remove feature flags once a feature is fully rolled out and stable. Leaving unused flags in your codebase can lead to technical debt, and maintaining them introduces unnecessary complexity. Every flag should have a defined life cycle. Make it a point to clean up flags regularly and eliminate dead flags to keep your codebase tidy. Next one, use feature flags for safe rollbacks. Feature flags are not just for gradual rollouts, they are also incredibly useful for rolling back features if something goes wrong. If a feature is causing performance issues or bugs in production, you can disable it immediately without requiring a redeployment. To act quickly in response to production issues, minimize user impact. And the last one, use A/B testing and metrics for data-driven decisions. As we discussed earlier, A/B testing is a great use case for feature flags. Make sure you set clear objectives and metrics before starting any A/B test, and use real-time data to guide your decisions. Having clear insights allows you to validate whether a new feature is improving user engagement or causing problems, and it helps you optimize user experience before a full rollout. Now, let's discuss common challenges. And the first one is obviously technical debt. It's one of the biggest challenges of using feature flags, and it's the potential of accumulating technical debt. Feature flags introduce a huge pile of additional complexity into the code base, especially if they are not managed properly. For instance, flags that are left in the code after they have outlived their purpose can lead to clutter and maintenance headaches. To mitigate it, make sure to clean up flags promptly and implement flag management tools that allow you to track and monitor flag lifecycle. Establish a clear process for flag removal as soon as a feature is fully rolled out or removed from the application. Then, security risk. Feature flags can introduce security risk if they are not implemented properly. If feature flags control access to sensitive features, such as admin panels or new payment methods, there is a risk that the flag could be manipulated by users or exploited by attackers. If flags are incorrectly set or exposed to unauthorized users, they might grant access to features that should be restricted. And to avoid it, always ensure that feature flags are secure. Prefer use only server-side checks to verify whether the user is authorized to see a certain feature. Never rely on client-side flagging alone, as it can be easily bypassed. Also, make sure that your feature flagging platform follows best practices for securing flag configurations. Next one, overuse of flags. Feature flags are an excellent tool, but overuse can lead to an overly complex system. Using too many flags or having them in places where they don't add value can lead to maintenance nightmares. It's easy to get carried away with flags, thinking that they can solve every problem, but they should be used thoughtfully. To avoid it, make sure each flag has a clear purpose and is tied to a specific use case. Regularly audit your feature flags to ensure that they are necessary and provide value. Next one, like conflicts and bugs. As teams grow, there can be conflicts between flags. For instance, if two flags are intended to modify the same feature or section of the code, they can introduce unexpected bugs or performance issues. Also, if you have multiple feature flags affecting the same user segment, it can lead to inconsistent user experiences. So ensure that the flags you implement don't overlap or conflict with each other. Define clear ownership of flags to prevent multiple teams from working on the same feature flag simultaneously. Communication between teams is key to avoiding conflicts. And the last one, depending on external services. Many organizations rely on external feature flagging services, such as I mentioned before, Launch Darkly or Unleash. While these services are powerful, they also introduce a dependency on third-party systems. If the service goes down, it can impact your ability to manage flags in real time or even affect user experience if flags control critical features. So make sure you have a backup plan in place for handling outages or service interruptions. Some feature flagging services offer fallback or allow you to configure flags directly in your code. Always have a strategy for handling failures in your feature flagging infrastructure. So while feature flags offer incredible flexibility and power, they come with their own set of challenges. By following best practices, such as cleaning up flags regularly, keeping flags organized, you can leverage feature flagging effectively without accumulating technical debt or introducing security risk. Managing these challenges proactively will help ensure that feature flags are a net benefit to your development process and overall application quality. And as we've seen, feature flagging provides powerful tools for managing gradual rollouts. Now, let's take a look at some real-world examples and current industry trends that highlight how feature flagging is being implemented in the field and how it's evolving. For example, Spotify. Spotify uses a feature flag to monitor releases, run experiments, and conduct gradual rollouts, to deploy features to select user segments, and analyze engaging data to decide on wider release, minimizing risk and iterating based on real-time feedback. This continuous testing approach helps Spotify enhance user experience while safeguarding stability. Same way it used with GitHub. GitHub relies on feature flags for smooth, uninterrupted deployments. They use canary releases, gradually exposing new features to limited users, which helps detect and address issues early. This method supports the high-quality, efficient release process. And the last one, let's discuss industry trends. And the first one, increased adoption. Feature flagging is now standard across DevOps and agile environments, allowing teams to separate deployment from feature releases, reducing deployment risk. Second one, centralized management. Tools like LaunchDarkly and Unleash help companies manage features flagged across teams, providing visibility and reducing mismanagement risk. Next one, CI and CD integration. Feature flags are increasingly integrated into all CI/CD pipelines, allowing state releases and smoother user experience control. Next one, microservices management. In microservices, feature flags offer precise control over service rollout, enabling isolated testing and quick rollbacks if needed. And the last one, enhanced security and privacy. Companies are prioritizing secure flag management, implementing strict access controls for sensitive or user-facing features. And as feature flagging continues to evolve, it's clear that this tool will remain a cornerstone of agile and DevOps practices, helping teams deploy smarter, test faster, and deliver a better user experience. As we wrap up this presentation on feature flagging, let's review the key points we've covered and summarize the key takeaways. And the first one, feature flagging increases flexibility. They allow for continuous delivery while minimizing risk. By separating feature release from code deployment, they give teams the flexibility to control when and how new features are exposed to users. Next one is data-driven decision-making. Feature flags are a powerful tool for experimentation. With A/B testing, you can make data-driven decisions, testing new features on a small group of users before rolling them out to a broader audience, to help you optimize your product and improve user engagement. Then, reduce risk during rollouts. By using gradual rollouts, you can mitigate the risk of introducing a new feature. This approach allows you to monitor performance and user feedback at each stage and avoid large-scale issues by addressing them early. Next, collaboration and organization, and they are key. As teams scale, it's essential to manage feature flags carefully. Good communication, clear ownership, and proper tools for flag management will ensure that feature flags enhance your workflow rather than adding unnecessary complexity. Then, be aware of security and technical debt. While feature flags offer tremendous value, it's important to address potential security risk and avoid accumulating technical debt. Regularly clean up old flags, secure feature flags configuration, and manage their lifecycle to ensure they remain an asset rather than a liability. And do not forget that feature flagging is an evolving practice. Trends like integration with CI/CD pipelines, adoption of centralized management platforms, and a focus on security are shaping the future of feature flagging. Keeping up with these trends will help you stay ahead in using this technique effectively. In conclusion, feature flagging is a game changer for modern software development, providing flexibility, control, and opportunities for experimentation. By leveraging feature flags, you can release faster, test smarter, and reduce the risk associated with deployment of new features. However, it's important to stay mindful of the challenges and best practices we discussed today to ensure that feature flags truly add value to your development process. Thank you all for your attention today. I hope you now have a bit clearer
Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on 4 powerful pillars: the Sharp platform, bringing Web 2 to Web 3; the Sharp token, fueling growth and rewards; the Sharp Rewards app, where you learn, earn, and grow; and the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth. Own your future.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
All right, everyone, welcome back to the Software Architecture Conference. We took a quick break for about 7 minutes. The previous few sessions, couple of sessions were recorded. Those are like small ones. That's why we took the recorded one. But we are back once again. We are live, and we now move to our third final session of the day. After that, we wrap up the day 3. Our next session is on Microsoft Fabric. Everybody's living Fabric now. If you are on LinkedIn and Twitter and you are from the Microsoft community, I think Microsoft Fabric is still relatively very new, and it is very well accepted by data developers and even from across the board. Joining us today is Kevin Chant, who is a data platform MVP in Microsoft Fabric. Wow. And he's a data platform professional, and he's going to talk about consideration when implementing CI/CD for Microsoft Fabric. Kevin, welcome to the Software Architecture Conference.
Hi, Simon. Yeah. Hi, everybody.
It's so good to see you, Kevin. You know, I love your background. I miss this van. We don't have it anymore. I don't see it very often.
I think it's more to do with the number of online events I've been doing as of late. So, yeah.
All right, Kevin. You know, we're all are very looking forward to your session. I have shared your screen. I've added it to the stream. Everybody else can see it. And next 30-35 minutes is all yours.
Well, thank you very much, Simon. And yeah, hello, everybody, and welcome to today's session, Considerations when Implementing CI/CD for Microsoft Fabric. So the agenda for this session, I'll quickly go through my bio because it is a short session-ish. Then I'll cover why to perform CI/CD with Microsoft Fabric. Then I'll talk about Microsoft Fabric version control. Then I'll cover testing strategies, then continuous integration maturity levels, then deployment strategies, and some other interesting points. So very quickly, I go through my bio. My name's Kevin Chan. Like Simon said, I'm a data platform MVP. I'm a lead technology advocate living in the Netherlands, various certifications, etc. And you can find me online in a few different places. So straight into it, and I want to say, first cover why to perform continuous integration and CD in Microsoft Fabric. And I'll explain why I say CD in a moment. So first of all, continuous integration so that you can merge your updates with Fabric items frequently. Ideally, testing changes to make sure that everything is in a workable state. And then continuous delivery to ensure that your updates are deployed to other environments in a fast and a repeatable manner. Now, sometimes people implement continuous deployment as the CD element instead. And that basically means that the updates, once they've gone through testing and gone into your development environment, are then automatically deployed to one or more other stages. So the benefits of working with CI/CD in Microsoft Fabric include faster release cycle, an audit trail of your changes, the possibility of automated tests at an early stage, and reliable and more consistent deployments. And in addition to that, it allows you to work with new industry innovations, because the reality is there are new CI/CD related updates coming out in Fabric every now and again. So with this in mind, I want to introduce Microsoft Fabric Git integration. Now, this is essentially version control for Fabric items. And it does this by allowing your metadata for supported items in a workspace to be synchronized with a Git repository. Or to be more precise, with a branch in a Git repository. So there's a direct link between a branch in a Git workspace and branch in the Git repository, I should say. Sorry, everybody, and a workspace in Microsoft Fabric. Now, in order to use Git integration, you do need a Fabric or Power BI premium capacity, and it can be any Fabric capacity, including F2 and Fabric trial capacities. And items are supported at various levels. So, for example, if you work with a Power BI report, in a workspace that's configured for Git integration behind the scenes, it stores a Power BI desktop project. Whereas if you're working with a lakehouse, it will store a container and maybe some other details like shortcuts, etc. as well, but not Delta tables themselves. Now, Microsoft Fabric Git integration supports the cloud-based versions of both Azure DevOps and GitHub. So in other words, Azure DevOps Services and the github.com offerings. So here is an example of the supported items with Git integration. I'm not going to go through all of these. It's not a long enough session. And as you can see, it's an impressive list of items. So there are benefits of working with Microsoft Fabric Git integration, which includes the fact that it allows you to track and manage changes to Fabric items. It reduces conflicts and allows you to have a history of the changes. It's based on the extremely popular Git version control system. So if you've been working with Git in the past, it's easy to get up to speed with working with Microsoft Fabric Git integration. And it enables you to perform CI/CD for multiple Fabric items collectively, which is obviously a great benefit. So there are various Git integration features I do want to highlight. For example, you can change items in the workspace and commit to the repository. And you saw the list earlier of the supported items. You make a change to those, you can commit that change straight to the repository. You can also update from the repository. So for example, if you store the repository in Azure DevOps, you can actually make a change to that repository in Azure DevOps and then synchronize that with the item in Microsoft Fabric. And you can also branch out to new workspaces as well to create feature workspaces. So effectively, you are making a clone of the item stored in a particular workspace elsewhere, but it's only for supported items. It doesn't magically do items that are not supported by Git integration. And it's worth bearing that in mind. So, with that being said, I'm just going to quickly go through a demo for you all now. So just bear with me. I will just go over to here, and as you can see, and I just want to go back to a blank workspace here. I apologize, everybody. So I have this workspace, blank workspace. I've imaginatively called blank workspace. And if I click on workspace settings, I can select Git integration. And then I can choose the Git provider. As you can see at the moment, is either Azure DevOps or GitHub. So if I select Azure DevOps, it asks me to select my Entra account. And I can click on connect. And then from there, as you can see, there's a fairly intuitive drop-down menu system I can use. So drill down to the organization, then select my project, then the repository, followed by the branch. And then if I want to, I can put in an additional folder. Now, a common practice that's appearing is that you add a workspace folder here. Now, I don't need to finish this off because I actually already did this for some workspaces. So for example, if I go to this feature workspace and I click on workspace settings and then Git integration, you can see here, it is connected to a feature branch in my Git repository. As you can see, I can see the Git status once I have Git integration enabled, and I have a source control button open as well. So if I click on source control here, you can see I've got an update because I updated behind the scenes in Azure DevOps. So just to add a bit more context to this, The changes here in the tab represent changes you make in the workspace, which you can then commit back to the Git repository. And then the updates represents updates coming from a Git repository. Now I can show you here is how the Git repository looks when you have Git integration enabled. So as you can see here, like I mentioned here earlier, there's some folders for the Power BI desktop project. So here's the metadata for your Power BI report. And here's the metadata for the semantic model. One key point to remember, it only stores the metadata for your items. It does not store any data for them. So I just want to highlight that here for everybody. Now, if I go back to Fabric, you'll see on the far right-hand corner, I have a little branch-like icon. If I click on there, this is where I can branch out to another workspace. So as you see here, I've already done this for a feature workspace, but what you can do is go into a development workspace, click and check it, branch out to new workspace, and then clone everything to a feature workspace. And this is ideal if you have multiple developers working on multiple features. And then they have their own environment that they can work with and do additional things. And that does bring me to a very nice, important point of some considerations when using Azure DevOps or GitHub. So the reality is that a lot of the time it will depend on what is currently used in your environment. So for example, if you're working in a large enterprise and you are using Azure DevOps in your enterprise, you have to ask yourself, is it going to be feasible and worthwhile to put the repositories in GitHub? And of course, the other way around as well. This is a big influencing factor. As you saw earlier, Azure DevOps uses Entra authentication. In other words, it uses Azure AD authentication, whereas GitHub at this moment in time uses personal access tokens per user. So if you are looking to use GitHub, you are going to have to think about a personal authentication token strategy for your enterprise. So Azure DevOps, as you probably know, can be region specific. So when you create a new Azure DevOps organization, you specify a region, and that means ongoing that all of the Git repositories you create in Azure DevOps are stored in that region in Azure. In the past, with GitHub, it was uncertain where your repositories be stored because they could be cached anywhere around the world. However, as of last year, GitHub have been introducing regions, and it now allows you to be able to request to deploy organizations specifically in the EU, Australia, and the US. So if the region, if you had geographical reason for geo reasons, had to use Azure DevOps in the past, GitHub may be a more appealing option for you now. And if you are looking to do a new adoption of either of these two services, remember to think about the learning curve. So for example, if you do decide to introduce Azure DevOps, mostly for the people that work with the Git repositories and the Azure Repo Service and Azure DevOps, bear in mind that they'll probably want to use the other default services in Azure DevOps to help with their way of working as well. So for example, Azure boards to manage work items, Azure pipelines for their deployments, etc. So bear that in mind. And just so I don't forget this, I am going to quickly put a link for Git integration for my moderator to be able to share with you all. So last September, Microsoft released a documentation about suggested CI/CD workflow options. And as part of that, they recommend this development process. So as you can see, this is using Git integration like we showed earlier, or it can be through an IDE with a Git repository stored on a local machine. And I can actually show you how that looks now. So for example, you could be using Visual Studio Code for everything locally. And then synchronize the changes to the branch in Azure DevOps. And then they say then to do a pull request to merge your changes to another branch for use for deployments used elsewhere in a variety of different ways, which we will discuss shortly. However, I suggest you take this one step further and you implement unit or integration tests. So the similar development process I showed you just now, as you can see, I'm using Power BI here as an example. And you do your changes to your Power BI report in your workspace, and then merge it with your feature branch. And I'm showing Azure DevOps here, but it could be in GitHub as well. And then when you go to perform your pull request, it actually runs a pipeline. Now, of course, if it's in Azure Pipelines, it'd be a pipeline, or it can be a GitHub workflow. And in this particular case, you can check using Tabular Editor to check the quality of a semantic model and PBI Inspector to check the quality of your actual report. And as long as the pipeline completes successfully, you can then merge your updates to the next branch on. Now, it doesn't necessarily have to be just for Power BI reports, so this is a key point I want you all to remember. It can be for data pipelines and other items as well. And with this in mind, I'm going to share a list with you of some ways that you can potentially test various Fabric items. So, as I mentioned just now, for Power BI reports, you can test with PBI Inspector. And in fact, work has been done recently with PBI Inspector. So version 2, and I do believe actually it's 2.4, now supports other Fabric items as well. So it may be worth looking into. For semantic models, you can use either a tabular editor in your pipeline, so use the tabular editor CLI, or use semantic link running through notebooks in Microsoft Fabric. But just bear in mind, or manually as well, of course, just bear in mind, if you use Tabular Editor, then the compute is done in Azure Pipeline. So in other words, on your Azure Pipeline agents. If you use Semantic Link, your compute is going to be done in Fabric. So you're going to basically use CUs. Now, to test Microsoft Fabric data pipelines, you can use the Data Factory Testing Framework, which is a testing framework that's available on GitHub. You can also use this, by the way, folks, if you're working with Azure Data Factory as well. So I just want you all to realize that. Now, for data stored in lakehouses, data warehouses, and KQL databases, depending on where you're keeping the data, you can use a variety of different frameworks, including Great Expectations, PyTest, etc. And then for SQL database and Fabric, you can look to use SQL code analysis. Now, it may seem like a lot of effort to implement these tests, but the reality is that the sooner you identify breaking changes, the quicker it's going to be to revert the change. And this diagram highlights it. So, for example, here, if you make a change to a feature workspace, for example, the impact is minimal because it's only affecting the developer working in that workspace, and they can easily revert their change. Whereas if we go across to the other side of the spectrum, if you have a breaking change in production, as well as taking a while to revert those changes, there's a potential cost and reputation impact as well. So with this in mind, I actually came up with a proposed Microsoft Fabric continuous integration maturity level set that you can look to use. So for example, and you've probably seen similar maturity levels used elsewhere in the past. Level 0 is, of course, when you're doing no source control at all and when you're just purely working with Fabric items. And then level 3 and 4 is when you're doing more testing on further items. And for enterprises, I do recommend looking to get to maturity levels 3 or 4. So that's testing strategies. And I want to quickly cover now about deployment strategies because, as I mentioned, Microsoft released an article last September. And in that article, it includes the previously shown recommended development process, and offers a continuous integration, but it also covers some recommended release options. So with this in mind, I enriched these with additional considerations for deployment strategies. So I'm going to go through these 4 different options for you now. So first option they have is Git-based deployments. And this is where you have all of your workspaces connected to different branches in the same repository. So for example, as I showed just now, you could have a development workspace connected to a dev branch and a production workspace connected to a prod branch. And then from there, you can actually merge your updates to the different workspaces via pull requests. So for example, make a change. As I showed earlier, if you make a change in a feature workspace, do a pull request and say, I want to merge my change over to the development workspace. Or of course, do the same from development to production. Now you can do this manually in your application lifecycle management service of choice, or with Fabric Git API supplemented by a few other APIs as well. And here's a diagram to show you how this can potentially look. So as you can see, a bit like earlier, use the same development process to update your next branch on effectively. And then you can update your workspace. And it can be other workspace branches and workspaces after this as well. Now, some guidance relating to this. Obviously, Git knowledge is required. It's ideal for scenarios that require only minor source changes. So, for example, if you just need a small change to point a report somewhere else, then it's possible. But of course, if it's a lot more complex scenario, it may not be the best option for you. It is ideal if you want to, for example, deploy the same report with the same resources, same sources to multiple workspaces, etc. And I do recommend looking to automate this source process if you are looking to do this. Now, option 2 is Git-based deployments using a build pipeline. And this is where you deploy the different workspaces through a suitable pipeline deployment service. So ideally, Azure Pipelines, if you've got your Git repository in Azure DevOps, or GitHub Actions, if you've got your repository stored in GitHub. Now, these are typically done with either directly calling the APIs or using another set of tooling as a layer of abstraction. And Microsoft's recommendation is that the workflow for each stage contains a build for unit tests and a release to perform the update. So here's a diagram to show how it looks. So again, the development process up until your next branch, which in this particular instance is a main branch, and then the pipeline runs to do the deployment to one or more workspaces for you. Now, some guidance relating to this. Again, knowledge of the application lifecycle management service is required. If you're working with Azure DevOps, you're going to need to make sure people have knowledge about Azure pipelines. And if you're working with GitHub, they are going to need to have knowledge of working with GitHub workflows and GitHub Actions. So bear that in mind. However, this is ideal for more complex scenarios or when you want to implement data ops. So some real world examples include if you want to have an approvals process, or you want to deploy multiple items to a Fabric workspace and then run a notebook afterwards. So for example, deploy a lakehouse and then run a notebook afterwards to actually populate that lakehouse with data. So this is ideal in those kind of scenarios. Now, if you are looking to use this scenario, I do suggest looking at tooling to be a layer of abstraction over the APIs. These can be PowerShell modules, or the Fabric CI/CD Python library, or the Fabric command line interface. Now, the last two you may not have heard of, but they are gaining in popularity. And I'll actually put a link into the chat for the pair of them so more information can be shared. And the reality is that you can even use a combination of any of these three together, or even all of these three. So for example, you can use a Fabric command line interface to actually create a new workspace for you in Microsoft Fabric if needed, and then deploy to that workspace with the Fabric CI/CD Python library. So what I can actually do, and I will actually save this to the end, I will do some demos for everybody on these options towards the end. So option 3 is Microsoft Fabric deployment pipelines. So this is actually something that's driven directly in Microsoft Fabric. So you can update a workspace that represents different development environments or stages, and then orchestrate with Fabric deployment pipelines. And in fact, this is a bit wrong. It should be to do the development process as typical, and then from there use Fabric deployment pipelines. However, this diagram does make it clearer for you all. So on the left-hand side is pretty much the same development process that I mentioned earlier. And then you go through this development process, you then deploy your updates to a workspace that represents the development stage in a Fabric deployment pipeline. And then from there, orchestrate it in Fabric, the deployment to the different workspaces. However, what you can also do, and this is useful, especially if you've got older deployment pipeline stages, but you now have more complex scenarios required, you can actually orchestrate the deployment to your deployment pipeline stages with Azure Pipelines or GitHub Workflows as well. In this particular case, I show Azure Pipelines, but it can be GitHub Workflows. And this can be useful, for example, if you want to have approvals before deploying to a particular deployment pipeline stage. And now I've actually covered those two, I'm just going to quickly do a quick demo for you all on the last two options so you can see how they look directly. So first of all, in Microsoft Fabric, I'm just in Azure DevOps, I should say. Sorry, everybody, just really keen. So I just want to quickly show you, for example, how you can use the Fabric CI/CD Python library. So here I have a release pipeline in Azure DevOps. For the benefit of this demo, I'm showing it to you with a classic release pipeline, but in reality, you should strive to use YAML pipelines. So here I've just got some basic steps to specify a version of Python, install the Fabric CI/CD library with a PowerShell task. Here I'm authenticating as a service principal, but in an enterprise, ideally you want to have this as a service connection. And then you can just run a Python script to deploy to an environment. So in this particular case, I'm running the Python script that's stored in the Git repository. And now I'm specifying some arguments. And if you parameterize your Python script, you can use the same script for multiple environments like you can see here. And this script is nothing more than, if I go back to my repository, it's just a Python script that I've got stored here. Oh, wrong one. So I have to go here. Sorry, everyone. I have to jump to the other repository for you. So it's just the script that you can see here. So that's how you can use Fabric CI/CD to deploy to multiple workspaces. As I mentioned, you can actually use Fabric CLI and Fabric CI/CD together to create a new workspace and then do the deployment. This particular demo is in the YAML pipeline, by the way. And I won't go through all the code. What I'll actually just quickly do is show you how the completed stage looks. But as you can see, you can do it or specify it all with YAML. And there is a real world situation you can use it for. So for example, the fuel monitoring solution that you may be aware of, what you can actually do is use Fabric CLI and Fabric CI/CD together to actually deploy fuel to a new tenant. So get it to create a workspace in a new tenant and then do the deployment from there. Now I'll quickly show you how the Fabric deployment pipelines look. So within Microsoft Fabric itself, you get a nice GUI here, which you can do things like choose various items to deploy, etc., to the different stages. Now, I do have some guidance relating to these deployment pipelines. They're ideal for business citizens. As you've just seen, they are GUI based. You can also apply various deployment rules, such as changing data sources depending on the type of data source. And as I mentioned, when the requirements go beyond the capabilities of deployment pipelines, you can look to orchestrate your existing deployment pipeline stages in either Azure DevOps or GitHub. So option 4 is if you want to deploy to multiple client solutions, tenants, etc. So in other words, deploy to multiple tenants. This is very similar to option 2, this recommendation. So basically, all the development and test work you do in your own tenant, and then you deploy it to workspaces and other tenants via your application lifecycle management of choice, like you can see on this diagram here. Now, I do have some guidance for this. It's mostly aimed at ISVs, but it is useful for certain scenarios like custom reports. If you are going to go down this route, I personally recommend implementing option 2 internally for consistency. Of course, it depends on the various business cases, but it does mean then your developers have got a consistent way to do the development work. And my final consideration for this is to ask if this type of deployment is the right option for you and your business, or would in fact hosting a Fabric org app internally and sharing it with external entities be a better option, or even offering a custom Fabric workload. So that covers the 4 different deployment options from Microsoft. I got a few other quick things to say. So first of all, I want to mention about Fabric data warehouses and SQL databases in Fabric. You can do deployments of the majority of the previous options. However, the traditional way of working with database projects and DAT-pack files is still an option. And as you can see on this diagram below. So this diagram is based on SQL database and Fabric, but you can easily change it to be a Fabric data warehouse. And as you can see, you can either extract the schema into a database project, or you can actually create a DAT-pack directly from the source database or data warehouse, and then deploy it via an Azure pipeline or GitHub action. So I wanted to make sure you're all aware that is still an option. Also, another important consideration is developer machines, because when you're make these changes, not everybody is aware of this, but you do need to make sure your developers can still do their development work locally. So to work with Fabric items locally, and this is mostly applies to greenfield environments that your developers need Git installed locally, and a version of Visual Studio, If you're using Visual Studio Code, for example, your developers then have access to a variety of extensions provided both by Microsoft and members of the community as well. In addition to that, and I've thrown a bit of AI here, I do recommend GitHub Copilot to increase productivity, especially for developers who are going to be working, for example, with Python directly on their local machines. So for the Power BI developers, it's a similar stance as before. They do require Power BI desktop as well. However, bear in mind, if they are going to be looking to work with Power BI desktop projects, then they will also need Git and a version of Visual Studio, ideally to manage the Git orchestration. Or, of course, you can get them to learn the command line. Anyway, just to summarize everything you've seen here. So for best coverage of all the Fabric items, implement Git integration. Various Fabric items can be tested in an early stage, like I showed earlier. That includes Power BI reports, semantic models, data pipelines, etc. Strive to improve your continuous integration maturity level. So basically do automated tests and catch any potential breaking changes early on. There are various release options to cater for multiple needs. As I showed earlier, for complex scenarios, you can look to use, for example, Azure pipelines or GitHub workflows. For business citizens who want an easy way to do deployments in Fabric, they can use Microsoft Fabric deployment pipelines. For SQL-related offerings in Fabric, traditional SQL CI/CD is still an option. And remember to take local applications into consideration. So that was a fast session for you all. And of course, when this is available online, you can go back and you can watch this video again. And I'm sure there are some questions as well. And whilst I'm answering any questions, I will share my credentials again as well.
Perfect, Kevin. That was an absolutely amazing session. I personally love DevOps, so thank you. And I know it has become a practice these days. No software development can take place without a DevOps, so it's very good. Scott in the chat says, "Wow, that was an absolutely amazing session, Kevin." Let's take a few questions we do have. I think we did get it in the beginning. Yeah, this one is from Khan Singh. He's asking, what is the best way to handle environment-specific configuration example for development, staging, production within Fabric CI/CD pipeline?
There is actually a feature that was announced earlier this year by Microsoft. You can look to use variable libraries now. So go to your search engine of choice and type in Microsoft Fabric variable libraries, and you'll be able to see there how you can use them to handle your environment-specific configurations at a complex level, okay?
Perfect. We'll move to the other question. Thanks for asking the question, Khan. We'll move to the next one, and that is by Rohit, and he's asking, how does an organization manage the authentication and security of the service principal or identities used in the CI/CD pipeline to deploy to Fabric?
This is pretty open question, especially considering a lot of APIs support service principals now and manage identities, but not all of them. So typically, most organizations, if you're using Azure DevOps at least, they will strive to actually create service connections in their Azure DevOps projects instead of doing like I showed earlier, where you can also use PowerShell as well. All the organizations look to use Azure Key Vault where possible, and you can use these when you're using Azure pipelines or GitHub workflows. Strongly recommend using Azure Key Vault. If you can't use Azure Key Vault, for example, on GitHub, then at least use GitHub secrets to manage your service principals as well. So that is the short version of that answer. And the reality is, talking about security in Fabric is an entire session by itself. But I hope this answer helps you get started.
Okay. That's I know that's a very generic question, right? It's tough, but thanks for answering that, Kevin. We'll move to the next one that is by Sophia, and she's asking, beyond CI, continuous integration, how would you approach a continuous deployment pipeline for Microsoft Fabric, especially for a production environment?
Oh, that's a very good question. If it's continuous deployment where you don't want to have to have approvals in every stage, or you don't want a manual process, you would actually have the update trigger, for an example, in a branch done, and then for your development branch, for example. So you would still need to do your initial development process to update your development branch. And then in your pipeline, set a trigger in place for when your development branch is updated. And once that is done, you can use that as a trigger to start your pipeline if you're working in Azure pipelines, or your workflow if you're using GitHub Actions. So that's how you can do your continuous deployments. Now, one thing I will add to this, if you're looking to do this, I do still strongly recommend a form of approval process when you're going to production. It doesn't have to be a manual approval, especially if you're working in Azure DevOps. So, for example, it can be that you're checking Azure Monitor to check performance metrics after a change in your test or development environment. And if the metrics are, for example, show a degradation in service, don't do that release. You can put it on hold. You can flag it as an alert, etc. So that's how I would approach it. I would also approach the check, definitely, if you still need an approval to production, basically, but you do it by triggers to your development branch. Hope that answer helps, sir.
Thank you for answering that question, Kevin, and thanks, Sophia, for asking it. We'll take one final question before we move to the next session, and that is by Scott. Scott is asking, can you recommend a way to integrate automated testing into the continuous integration process for Fabric notebooks and data pipelines?
Oh, for testing the changes that are done through notebooks, you can use, for example, Great Expectations or PyTest, like I mentioned earlier. For data pipelines, I strongly recommend, like I mentioned earlier, the Data Factory Testing Framework, which you can find on GitHub. And I actually did a blog post about this as well. So if you go into my blog and you type in automate data pipeline testing, you should be able to find the blog post where I actually go through the steps required to set it up to automatically be done for data pipelines in Azure DevOps. So I hope that helps.
Perfect, Kevin. So that is all we have from the audience as a Q&A. Anything you want to add before we wrap up the session?
The thing I've got to add is thank you very much, everybody, for attending. And I hope you've enjoyed this conference.
Yeah, thank you so much, Kevin. Thank you so much for taking out your time and sharing the pearls of wisdom. I'm pretty sure everybody who will be watching this session later on, they'll have to take a pen and paper and note down all the best practices that you have shared, because there's so much to be taken away in just about 35 minutes. We really appreciate it, and thank you so much for all that you do for the community. And we hope to see you in the other events that we do. Have a lovely evening.
You too, Simon, and thanks for having me. Thanks all.
Thank you. All right, ladies and gentlemen, that was Kevin for you with an absolutely amazing session. Now, as we move towards the end of day 2, our next session is actually by Rohit. And it still have, I think we have about 5 minutes before we go live, or we don't. Let me see. Yeah, it's actually now. We'll have to text Rohit, our next speaker, to please join. Until then, please enjoy this commercial. It's the only commercial you all know you have been watching.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
All right, everyone, welcome back to the Software Architecture Conference. We now move to our second final session of the day, and that is on revolutionizing data collection with NVIDIA's Agent IQ. I really don't know about Agent IQ. I've never seen anybody using it. I know there's a Agent Q, by Amazon. Is that Agent Q or something? I don't know. But yeah, it's I'm really excited for this session. It's by Rohit Gupta, who's a consultant, senior member of IEEE, mentor, tech leader. Hi, Rohit, and welcome to the Software Architecture Conference.
Hey, Simon. Hi. It's nice meeting you and welcome everybody. And thank you so much for giving me this opportunity. I hope I'm sounding clear and visible, clear.
Yeah, your sound is very crisp. You look very happy and charming, right? Lovely session, right? We can't wait, to learn from you. Please feel free to go ahead and share your screen, and then we can get started.
Yeah, let me see.
From the bottom of your screen, you'll find a plus icon. Click on share screen, and that should take you.
Yeah, I hope you can see my screen.
It's loading. Yeah, I see you are inside your slides now. Do you
yeah.
want to click on that hide link? That there's a pop-up that says StreamYard is sharing your screen. Next to stop sharing, there's a hide button link. Yeah, perfect.
Yeah.
Everybody else can see your screen, Rohit. Next 30-35 minutes is all yours.
Thanks, Simon. So hey everyone. I know this subject is like a lot of fires nowadays. This AI and especially NVIDIA, those who have the stocks, so they are pretty much very happy with NVIDIA's stock performance. But I would like to highlight one point here that this is a toolkit which was provided by NVIDIA long back. I mean, I think like a few months back when there was no much hype of the like all these agent tools and like AI chatbots and agent as a service, those kind of stuff, which is now like pretty much very much popular nowadays in the market. So I created, like I'm already working on some of the AI chatbot and tools in my current role. So thought of getting some insight on this. So I got opportunity to work as a senior developer in the NVIDIA, and I got some certification as well for this Agentic IQ. So let me straight jump into the topic. I know we have very less time. So this is NVIDIA Agent Intelligence Toolkit, which is created by the NVIDIA company, and this is open source. Like anyone can go and like they can get benefit of this open source toolkit. What it do actually? So how it is important for the enterprise system? So it helps to collect, to interact with the open source available data throughout the world. So my presentation today will contain majorly about these topics, like what exactly Agent IQ is, how it is differs from traditional data collection platforms. I put a use case as well for just for data fetching purpose and the presentation purpose, like Agent IQ versus TableView. And then why enterprise should adopt Agent IQ. And there is one POC which I created in my work environment. But I cannot show here the working because of security and compliance purposes. But I created one document in a very simple, basic manner, like how a layman can create a simple proof of concept. And then finals, like what are the takeaways and feedback, what we can get it from here. So yeah. So next is like the power of AI communication. So what exactly is an NVIDIA Agent IQ? So you can see like it's a versatile toolkit designed to integrate enterprise AI agents with various data sources and tools with a maximum compatibility, unlike traditional data collection platform like Google Analytics and there are some like open source in Microsoft and they're like different companies which basically works on the data collection. Like Oracle also have some data open source, but Agent IQ goes beyond by enabling framework diagnostic, and the best part is like it maintains the performance. It maintains the robustness of the data collection and the processing. So why Agent IQ? So it can work with like latest AI platforms like LangChain and Lambda Index and custom. You can create your custom Python agents. There is no need to, work with the existing tech stack. Reusability, like you can build your agent tools, workflows, and then you can repurpose on the different scenarios with the help of, very less time and very less resources. Observability, like nowadays we can see like there is a lot of open source platform like Grafana. We can create our own queries and we can create observability there, but it works like very, very well with the open telemetry. You can identify all the bottlenecks in the workflows. And then of course, like user face interface, which interacts with agents with the help of Agent IQ UI for the real-time visualization and debugging. So it basically, and the last point is like MCP compatibility. So MCP compatibility, I can share like it supports the model context protocol by enabling developers to use the toolkit to access tools served by remote MCP servers, or like you can create your own agent with the help of MCP registry. And like basically it helps to enable all your working environment for with the different agents. Like if you have some agent which is only responsible for image processing, and one agent you establish for text to like voice to text, and one agent you created for just go with the go and search like all the existing Twitter handles, right? So if whatever agent, so it very well accommodate with MCP, and this Agent IQ comes in picture when we have very less awareness of the MCP protocols. So that's why it is now people are aware of MCP protocol, but it's because it is so much popular, and it works with a lot of like LangChain, QoI, and custom frameworks. But NVIDIA accelerated computing with AI chips. It is like far ahead with this complexity. So now, how is it like different from traditional data collection platforms? Traditional data collection platforms such as like Qualtrics and Google Analytics, they depends on surveys. They depends upon their existing clients, like IoT devices, which is already plugged in a lot of places. So that's how and either you have to go with the paid data source. But with this AI enablement, you don't have to worry about like data breaches and compliance issues. These are like, and then you have this limited processing. Like of course, like ETL tools take a lot of time, and there are like bunch of bad jobs and decision handling workflows and all those things. And then of course in the last, like integration, which is a big pain to connect the existing system. So these are some of the drawbacks which is overcome by the Agent IQ. How it improves the data flow? It enhances the integration. It improves data quality, scalability, and real-time workflows. Like they have like Agent IQ and API, which serves like enable streaming, especially like streaming and non-streaming transaction for real-time data interaction. So those use cases works very well actually, because why? Sometimes we need like for example in a live soccer match, you need like accelerated response. So in that case, like accuracy, like a stock market application, right? So we need like accuracy. So this kind of agentic system, so what internally do, it actually, the agent toolkit collects like a lot of metrics and connect with your observability and orchestration tools. And then it understand the workflow, identify all the areas of improvement, and it debugs input if you see any kind of issue. So all these happens on the fly with the help of Agent AI IQ, this module. And then if you are using on NVIDIA AI chips, it increase like a lot. So basically, it accelerates your agent response. It accelerates your fine-grained telemetry to enhance your agentic workflows. So these profiling data can be used by NVIDIA NIM and NVIDIA Dynamo to optimize the performance of agentic system. It doesn't require that you have to use only agent like NVIDIA AI chips, but if you want to improve your system, so then you can include those interfaces, those inference call to an LLM for a particular agent, such as like a prompt is in memory, but it might reside with other agents, and it can call to more efficiently to those workflow by using NVIDIA Dynamo and NVIDIA NIM. So these are two main I can say like telemetry mechanism to enable all the business outcomes and fine metric collection process, which increase like accuracy and the decision making system on runtime. So I'm just focusing on real time workflow because NVIDIA is very like capable of collecting those metrics because of help of their memory and AI chips. So yeah, so let's move into the next slide. This is a very short representation of like how Agent IQ can be combined with a Tableau just to present data, because Agent IQ works on that background, but Tableau we can use as a presentation. So now, so collecting the data, like Agent IQ gathers data from multiple sources, preparing it for tools like Tableau, and you can use any other tool as well. It's just a use case. So unlike Tableau focus on visualization, Agent IQ supports AI-driven agents that can reason, plan, and act on data. It provides observability also because of like Agent IQ profiling and open telemetry integration, offer deeper insight in data pipeline performance, and complementing Tableau output focus analysis. Agent IQ and Tableau form a powerful pipeline because, as I said, like it just collect the data and Tableau, present the data to stakeholders. So why enterprise should adopt Agent IQ? That's a very big question. Like why enterprise should adopt? So number one is like because of NVIDIA AI chips, they have very special direct connection with to their interfaces to their memory providers, which help to collect the real-time metrics, which help to for a developer for a rapid development. And it's a start with a pre-built workflow and customize them to fit a specific need as per the project timeline. So cost efficiency, like it's a very cheap nowadays. I mean, I recently heard with that Twitter announcement, like I think they just launched like $250 or $180 smallest like chip, which is like very cheap as before that it was like $20,000, $25,000. They launched like a few years back. So that's like as the time grows, they can work more on the end, and the cost, of course, will reduce for the bigger enterprise and bigger data centers. And then, of course, like enhanced data decision making, future proofing. With all those use case which is planned for 2025, Agent IQ stays always ahead with the enterprise need because it works directly with your hardware. So that's just an example, like a retail enterprise could use Agent IQ to collect customer feedback from survey, like just like a runtime, like for example, Amazon, and then at the same time, it can collect survey from social media or the running transportation truck or rails from their IoT sensors, and then it can like transform the analysis in Tableau or data warehouse like Snowflake. So the runtime flexibility to control the mechanism and to collect the metrics with the help of hardware chips, I think that is the most important reason why enterprise should adopt. So now, so mostly, I would like to mention one point here actually, like how actually this how this event occur actually, like how this orchestration occur. So so for example, if any user or any event push to orchestration agent, right? Then orchestration agent, what will do, it will push like there are like basically three kind of agents, like diagnostic agent, planning agent, and reasoning agent. So then a planning agent basically works with the documentation and coding agent. So that's how this orchestration and the event enabling works. And then these two agents get enrolled by using like a lot of our platforms like databases, repos, documentation, RAG model. So these kind of architecture, this whole event orchestration actually work behind the scene with Agent IQ. So that is one of the big achievement for Agent IQ, because it works parallelly with a lot of orchestration agents, and which can scale up to like any scale. I don't think like it is limited to any scale. So yeah, then there is a simple proof of concept I would like to engage here directly. That was just a theoretical part, like how we can work with that. So there is already one NVIDIA a whole website based on this. There is a link that is I can share this PowerPoint presentation as well if someone wants. But yeah, I mean, if you can basically create a repository, like you can test your pre-built workflows like simple calculator or text file ingestion, or understand like how Agent IQ work. You can customize workflow because this is open source, so you can tailor your data source to your enterprise. I mean, there is no need to take license. A small business or any startup or a big company, they can just go ahead. They can replicate the whole source code in their virtual private network, and then they can customize. They can tailor the whole workflow, and then you can of course leverage the UI. And then evaluate the performance and see like how all these metrics, agent evaluation techniques, and how these work. Yeah. Then this is a sample POC I created. I mean, I already created one project, but I don't want to show here. So for this presentation, I created a simple document where I wanted to utilize like how it works. So this sample project, what I can expect this project like this, the agent will use the Wikipedia tool for the information as a data source, and the custom calculator for the math operation, and which can combine by outputting this response. And there is a test and validation, various question like math and all those things. Validate our LLM response with, and I'm using I think LangChain in this POC, so I can show you once. Then potential extension, like how can you extend the existing interfaces, how you can implement the multi-agent collaboration by updating the workflow to a team-based structure, how important to evaluate the metrics using the toolkit by profiling feature. And then you can create a web service by using Fast API, all those framework, and then this is just a basic project for AI agent system by using LangChain. But yeah, you can create, like you can, if you're not using, if your enterprise is not using any specific agent, then you can create your own REST API, and or you can create your own wrapper on the top of your existing application, and then you can use that. Let me open my. Okay, 1 second. Yeah. So this sample POC is like you can say like the way it is implemented. There is an already one agent toolkit provided, which is like React-based AI agent capable of querying external resources, and then this agent integrates with a large language model hosted by NVIDIA and NIM, and then basic observability logging extension. So this is just a sample proof of concept. The project focused on the command line tool that processes natural language, and the output, which is designed with the GenAI agent development. So these are just a text-based thing, yeah. So this project objective, as I mentioned, like it will implement a React agent workflow. It will integrate external tools by data retrieval, and it will provide logging and error handling, enable easy configuration via YML files. So prerequisites, we have like Python 3.11 or 3.12, the Git installed. If you have Git, I mean, you can create, and then NVIDIA key, you can obtain from like NVIDIA website, you can create one NVIDIA API key, and then you can use that. And then of course, like the hardware requirement. So how you can create a POC, you can simply create a directory and just like make directory next agent project, and then go into that directory, cd Nemo agent project. So how, I mean, why it is called the Nemo agent project? Because they recently renamed also. Like previously it was called like Agent IQ, but yesterday night I was reviewing this, so I came to know like they renamed into Nemo actually. And there is they created by, there is one sample POC on their website also. You can use that POC as well if you want, but this I created for myself for this presentation, so I can and this is based on Python. So the second command, then you have to initialize the Git repository, like just by using text and Git init. You can set up, the third step is like set up a virtual environment for dependency management. This UV, NV, this is the exact command. On the Unix-based system, you can activate on the window by using this command, and then you can create your you can clone their existing agent toolkit as a dependency. So first you have to clone their like this is their main like repo for the Agent AI toolkit, and then clone it. You go into that directory. You just have to like fetch one command for update their modules, because sometime it got outdated. So in the recursive manner, you need to update this. Then you have to install this LFS. This is one package which is required. Then just pull it, fetch it, and again you have to install this agent toolkit, like pip by this command. Yeah, and if you have like environmental variables is not configured, so you can create and you can like configure with the environment variable here in the Python project directory. And so yeah, so this is kind of a structure of the project. The main source code, then your main file where your main Python script will be assigned, and then configuration in the agent workflow. So configuration, like for example, if you're following like MCP protocol and you have to connect with the different LLM agents, so all this configuration you can put it here. And for observability also, you can include observability also. So for that you have to create account in LangSmith, LangGraph, and LangChain. So LangSmith is one of the tool associated with the LangChain. There you can create account and you can use that API for observability, and you can debug your Python application actually. And this is the logs for directory, and requirement, or this is just a Python project requirement where you have to like mention all your dependency, like how it is configure, how it can configure. Sorry, my phone. So how, I mean, what dependency, like all these Python files, all those libraries, all this dependency based on your project requirement, you can check those. Then README, of course, like you have to, yeah. So key, so this is one thing, and then yeah, YAML file. I know there are a lot of people who are familiar with Python, YAML. For them, it's just a basic thing, but yeah. So next, the function we can create as a Wikipedia search, and we can create some variable like max result and custom calculator for Bethy math. This is just a code base, like how you can create your calculation, and then based on the execution, you can return your value, and you can log your exception, everything. Based on your, you can include like more methods, like if you want to iterate your Wikipedia, like return result, and you have to pass to some other LLM agent to articulate some more calculation, like to pass into some resource handling module which can handle your text and convert into a voice, or to create a video or to create an image. So those kind of like things you can create here as well. I mean, it depends. And yeah, and the Llama, the model which we are using here is basically the Llama model. Why Llama model? Because Llama model is I think the best compatible model as of now, based on the popularity and based on the usage right now. What I saw with the Langchain, of course, with the various response and with the max tokens. The max token is like there's a limitation to use that model. So that's why it is like max token currently. Then for workflow, you can, so I said like Langchain and LangGraph. So what I did in my real project, I created one account in LangGraph from where I control all the workflows for my application. But yeah, you can use your own workflow also. There are some there are some inbuilt workflows as well for the from this NVIDIA agent toolkit, which you got cloned. And for database, actually, sometime like because for us we used open source, in which our application uses SQL Server, but there are some vector database which is already inbuilt in this NVIDIA agent toolkit. So those you can use for your POC purpose. And the enterprise, like any enterprise, can use those vector database based on their existing databases on the platform. So then the code works like this. The Python is shaped like, import logging. And this is our main code, logging.basic config. This is handling the log file. You can run and this is the main course code for running the agent. So run a given query and config path and all those. I mean, I don't want to go into line by line, but this is a complete POC I can share. Yeah. So the way it works, it can fetch the information from the Wikipedia page and procure as an output. So expected behavior, like piece of information for the math operation, logging, and potential extension, these things I mentioned already. So we were at Tableau, and then yep. So I think this is with the sample POC. So if anyone have any question at this point before I move further, Simon or anybody.
Questions we can take towards the end of our session.
Okay. Okay. Yeah. So this is the way it works, the way I highlighted this this whole presentation, because this we can take away as a future of data collection, because right now in the traditional application we use a lot of traditional methods, all the low level data mapping to create database connection and to fetch the data, or we use like Azure cloud or any kind of open source. But Agent IQ providing us a lot of flexibility to talk with our data collection platforms, which I just showed as a form of POC with the help of Wikipedia. And then we are getting an enhanced interface for our application with the help of AI chips, which is of course from NVIDIA. So this whole ecosystem makes it very advanced, and like it's just a ready go solution, and we don't have to write all those data entity layer and business entity layer and all those processing models, like how it is processing and how it is converting data and fetching all those. So I think all those era is little bit getting old, I would say, with the help of these data collection platform. And this is open source, anybody can go and use there are Cosmos database you can use your OpenGrace SQL database, you can use MongoDB. There are a lot of other vector DBs. So I can say this particular system will force me to think a data collection as a service. So you can create your own custom solutions which can help other enterprise to collect the data. And just like you can create your own custom collection data platform and just create an API and just share those APIs to your customers, so that they can just connect with the help of your custom data collection platform. They can connect to any of data source, to any of the API. And since this is around the AI agent as a service ecosystem, and with the NVIDIA AI chip, it's make beautiful arrangements for the end user. So this is my final takeaway. And thank you so much, Simon and whole team. This is my LinkedIn, this is my email. And if you have any question, I think I'm good with my presentation now. And over to you, Simon.
That's absolutely amazing session, Rohit. Thank you so much. We have definitely few questions from the audience. Let's take that. I'm going to first take the question from Sophia. Sophia is asking, what is the most significant advantage of using NVIDIA Agent IQ for data collection compared to traditional ETL tools?
Yeah, so in traditional ETL, we have to create a lot of jobs, pipelines, batch jobs. Like Control M is the #1 platform right now for batch queuing jobs. And then we have to create whole workflow queuing model, track what is coming, what is outgoing. This Agent IQ platform is providing us an inbuilt custom open source library where it's just a matter of few commands. You just saw how by just giving hardly 5 to 10 commands in Python script, I was able to collect whole data source. And there are a lot of inbuilt function, inbuilt workflows in this open source. If you can dig more, there are a lot of hierarchies, all these provisions are there. That you don't have to use because with the help of MCP protocol, this whole your solution will act as a MCP, and that can connect a lot of other agents. So instead of instead of you writing all those pipeline for ETL applications, your application will act as an MCP server, and it can connect to various agents. So all your data collection platform, or like from your, for example, if you're collecting data from website and you're giving data to mobile, so all these will act as a separate agent, and your solution will act as an MCP server. And that's how you can manage all workflows. So the whole ETL concept is I think is running away now.
Perfect. That's very good to know. There's another question from Sakshi, and Sakshi is asking, how does the agentic workflow concept in Agent IQ differ from a standard data pipeline, and what's the use where this approach is a clear winner?
So yeah, so I think it's pretty much similar to the previous question. So we have to create like a lot of pipelines even right now with the ETL frameworks. But with this, we don't, since our agents are available, we have the functions and build functions, all those metrics which are getting exposed with this open source code. All these matrices are available. I mean, all those functions are available. We don't have to write different pipelines. So I mean, it's all like as I said, like it will completely emit the pipeline and the job queuing and the ETL processes. It's just collected everything in a one custom built MCP based solution. So
perfect.
Yeah,
that totally makes sense. Yeah, that totally makes sense. The Scott says, lovely session. There's a question by Rohit. He's asking, how does Agent IQ handle scalability and performance when dealing with massive volumes of real-time data from various sources?
yeah. So I mentioned one there is a capacity limit like 512 in the workflow right now in this model. But that limitation, that scalability, of course, we have to add some more servers, chips, and more like data processors, like more NVIDIA chips. Basically, it's just like we have to keep like the sky is limit, right? So you have to. I mean, the more CPU you add, the more it is scalable it would be. So right now with one CPU, it's like 512 limit, but 512 is also huge. But scalability doesn't matter here because it's just work with one CPU, and if you have to scale more, you just have to increase your data center capacity. That's it. You don't have to write another code for scalability. It's just a data center. Like based on the traffic, it will adjust automatically. Just like right now we on the Azure cloud, it's like based on the request. Like if you're like overnight, if you got more requests, it will automatically increase your CPU to your workflow with the help of chips. So those throttling and those like load balancing, everything is managed very well by NVIDIA chips. So those risks and those issues are not be a culprit here. So we don't have to worry about the scalability at all. It's automatically managed by NVIDIA chips and this whole infrastructure.
Perfect. Thank you for answering it so detailed. We'll take one final question that is coming from Hemant. And Hemant is asking, how does Agent IQ ensure the data quality and consistency of the information it collects from different sources?
So, I mean, you have to validate it actually. So,
Okay.
Yeah, I mean, you can create connection, you can create all those dependencies in your solution, and then you have to create the wall. You have to validate it by using, your own function, like the data is valid and the well data is going. So that's not being controlled by the solution. But yeah, there are various functions. So like for example, just we use like math calculation. So you can control. I created one function there as well. Like I validated whether the property is integer or a string. So those kind of like normal validation, you have to do it for your data. And yeah, of course, I mean, you have to use your raw data. So because if you, I mean, you don't have to depend upon any unethical data. So once you get the proper valid data, you can put those normal validation and restrict the quality and improve the seamlessness. So yeah, that is something which application owner need to be controlled and validate.
Perfect. I think that is all we have from the audience. And, thank you so much for sharing your pearls of wisdom with the audience there. I think everybody is watching, I encourage them to go back and rewatch and explore Agent IQ. I think it's as you say, it's been there for a while now, and I bet it has evolved over time. So any final thing, Rohit, you want to add before we wrap up the day?
Yeah, I mean that's a wonderful platform, and that is I mean people are still using a traditional data entity layer, business entity layer, and there is a UI, there is a backend, there is a business process middle tier. So I think it's time to just jump on the like these kind of like solution wrappers where you don't have to write separate layers, and it will act as your MCP server. So basically every application is an MCP server now. So MCP, you don't have to, so that's a basic funda I wanted to share and impact much more at this time. But yeah, but thank you, Steven, so much for giving this opportunity. And I mean, this is the way I think. Maybe I could be wrong, but yeah, the way it is rapidly developing this whole AI ecosystem, we don't know like what could be the next, but this is what I can think now. Yeah.
No, you're absolutely right. This is the fourth edition of the software architecture conference that we are doing. The first one didn't really have anybody talking about AI and architecture, but if you look at the last one, and if you look at this one, everybody's talking about AI. This I think we should rename it to AI software architecture conference, something like this, because AI is everywhere. So thank you so much, Rohit. Thank you so much for sharing pearls of wisdom. I think it's an honor for me to host folks like you. I take it as my honor. Thank you so much. Have a lovely day ahead, and hope to see you soon in some other conferences that we do. And if you ever visit India, we do a lot of in-person events. We'd also love to host you there.
Sure. Thank you so much, Steven, and thanks to whole your team. And have a good day. Yeah. Bye-bye.
Yeah. Thank you. All right, ladies and gentlemen, what a fantastic session to wrap up the day 3 of Software Architecture Conference. We've had about 30 plus sessions in the last 3 days, and we actually wrap up the day 3. Tomorrow we're going to be joining at the same time as we joined today. And I want to thank everyone for sticking around. I still see a lot of you folks, for instance, Hemant, Rohit, Sakshi, Sophia, Khan, Scott, and quite a few folks for being with us from last almost 6 hours. So thank you so much. This is it, ladies and gentlemen, the day 3 of Software Architecture Conference. I'll see you tomorrow, same place, same website. Just come to Software Architecture Conference and you'll see the updated link. That is it, ladies and gentlemen. It is 11:55 p.m. at my place. I'll take a few more meetings and then I'll wrap up my day. I wish you luck and see you soon.